recording. So let's go. So what is a piece of memory, right? So for the recording purposes, we're gonna do today the flow control instructions. Um Wait, are these are the ones that no? You said logic and arithmetic they don't need memory, right? Do the
Yeah,
flow control ones need memory? I believe so, or no?
they do because the program lives in memory, right? And
Yeah,
then we fetch the instruction from memory, and then we execute the instructions, and
yeah. Okay, so
that
my first question is,
presumes,
what is a piece of memory?
well, for the purposes of this particular architecture, a memory is an array of words, and then a word is basically a signed integer of a particular size. Uh, The paper actually uses a machine that has 32-bit words. Obviously, we will probably vary the size because we are using like native integers, which in our case is 64 bits because that's the architecture we're using, right? We're on x86 64.
Yeah, but I think I asked the wrong question. My question is like, you said it is an array of words, and a word is 32 bits. Is that what you said?
Yes, in the paper, the award is 32 bits. We can probably do an array of IDs or integers or whatever is the Objective-C basic integer type.
I forgot. Magetta did this back in the day, but I forgot here. I forgot the thing. No, we already went full blown stack. So yeah, that's a problem. Oh no, that's not a problem. We can just borrow from the stack. I'm dumb. Here. So this is gonna be memory, right?
Yes,
An NS mutable array. I think it's a mutable array of what? It's a
of
mutable
objects,
array
I
of.
guess.
It's an object, but I think that's fine in here, right? You said that it
Uh,
can be an array of IDs, so I think it's fine.
it's fine. Like the specific width of the memory cells doesn't actually matter. Like it can be 32, as the paper says. It can be 64, which is more convenient for us. It could be 21 bits, which is something that Chucky Moore actually did with his
Mm,
green erase chips. Or was it 18 bits over there? I don't recall actually. Anyways, it can be whatever. So it's fine if it's just an array of pointers or pointer-sized integers, I guess.
okay, so for now let's go with IDs because I think that makes a more sense for Objective C, and we also need to initialize the memory. How about that? So memory. Because in the future we may do separation of what is code and what is data, I'm gonna put the RAM here. Okay.
Um, I mean, I wouldn't necessarily. That would actually be a bit difficult if you look at the instructions we're going to implement, but okay. I mean, you could separate RAM and ROM. That makes sense.
That's what I
But
meant.
having, yeah, that's fine. That's fine then, I guess.
Okay, so let's go to the stack and let's see how are we actually. Okay, so this is how you do it. Good to know. So let's just say that we have a mutable array, and we should also should clear the memory once we have cleared the code and etc.
By the
So
way, I
go on.
find it great that you're calling it memory RAM when the M in RAM already means memory.
When what?
The M in RAM already means memory, so it's a memory random access memory.
Okay, that's cool. So what can we start with? So let's go to the paper. So the first thing that we need, control this. So let's go to opcode. Opcode. I don't believe we're gonna actually do what I said, right? So I don't know if I mentioned, but how to combine enums in C. So there is
Oh,
a paper that I found, no, not a paper. There is this that I found, but I'm not actually sure we want to do that. So I actually want to discuss that with you guys. So
oh, that's messy. That's very messy.
so this is a way to have separate enums, but then you have one that sums them up, let's say. And I want to discuss if this is a good idea or a bad idea. Because if we don't go this route, you're gonna have a gigantic enum,
I
which is fine.
mean, I mean, like, I don't see why not, but you know,
Oh, I
I
can
don't
see
like
why not. I
the
can see why not.
no, I
Because
don't like the comparison and this thing that you're pointing at right now because I don't know, man. Coming from Lisp, that feels very wrong to me somehow, and I can't explain why.
well, something that we could do the following. Just because this is going to be the second set of instruction, let's do it. And then if Mageta found a, because I know the argument, right? The bad argument is that every single time you add a set of instructions, you need to add it to the main one, and you need to do the math to see if it's gonna fit.
That's not really the argument, I guess. Hmm. I mean, it's doable, but that's not really the objection I would make. The objection I would make is that the instructions are all numbers within a certain range, right?
Yeah,
And they may not occupy the entire range, but they all belong to the same range, right?
yeah,
So logically, it would make sense that they were a single enum, because an enum is basically a range of numbers. We have numbers that belong to the same range, so
no,
there's
but the main
an
argument is
obvious.
the physical separation. Because you can say that logically they are the same, which is true, but the reason to do this is actually a physical thing. Is actually that, let's suppose that I have 100 lines of code here for some reason, and then more 100 lines of code here. I don't need to care about the other ones because I'm only messing around with arithmetic types. Well, this is actually a wrong name. This is arithmetic operations. So I don't need to care about the rest of the code. I don't need to scheme the code, Like, because
I
if there
see.
are 50 opcodes here, I'm gonna have to, and especially if they are not like in blocks, like semantically in the physically close to each other, I'm gonna have to skim the thing to know what I want.
That's fair.
So the reason to do this is exclusively physical and a quality of
Are you
life, in
just
my opinion.
are you just justifying having a small brain? Is that what you're saying?
What?
Or you justifying? I come back and I hear you justifying have a small brain. You can't memorize which line everything is. I bet Nathan can, man. I bet Nathan can. After all, he's been coding in the same.
Yeah. So what we're discussing because we decided that we're gonna do this set of instructions today. So the flow control ones. And then I asked Marinho what he thinks about this sort of trick that people that I found on Stack Overflow to have separate enums, but they actually can be grouped together.
Right.
So they are logically the same, but they are physically separate. So then you don't have to scheme a 100-line enum to find what you want because it's semantically separated already.
I'll see. But they don't have a type, right? Because the other one is doing a type def. So
No, yeah, but I
I
think we can do the type def. Like you can do this and then do exactly what you did there. So in NSU integer, And then here is gonna be
Just one
opcode.
thing, the comparison being on like 100, right?
This is
Isn't
arbitrary.
that yeah? But isn't that the in correspondence to the max amount of enums that you can have inside of in the union?
Yes, yes, that's the downside that I was explaining to Marinho. We need to do the math.
Uh,
And man, this can get messy because okay, I think it's very hard for us to add 100 plus, but if we do,
actually, if you wanna go back a moment, Lemos, I asked this the other day, and you mentioned you plan on doing like 8 bits per instruction, right?
I don't remember saying that I planned. Maybe I said that I saw people doing it, but then go on.
So if you wanna do that, we're actually already over that number with that example you pasted, because that's hex, right? And a bit is just 2 digits, and you have three.
No, this is just an example, man. I just copy pasted this from Stack Overflow. Uh, this is just for the sake of explanation, man. We're gonna do another thing. Anyway, Mageta, what do you think about it? Do you want to have a gigantic OP code in them?
I mean, if you say you want, that's a strong statement, but I don't have an alternative.
No, the alternative is like
No,
this.
I know it's just putting everything on the same place.
Oh no, the alternative for the gigantic, yeah, the
Yeah.
alternative for the gigantic is this.
Um, Question: are we going to have actual code in this particular file, or just the opcode definition?
Just,
The
I believe only the opcode's definition.
Then why bother splitting them up if there's not gonna be anything in between them?
Well, because of what I said. Because then you don't have to think about which group do you want to mess around. It's already written. You can argue that we can add comments to separate them. Like flow control. And then here we can put stack manipulations. We can do that. Let's do that for now.
Yeah, I like that better.
For some random reason, my Emacs is not indenting
Yeah, I
this
think
crap.
that's more reasonable because you avoid the amount of instructions problem. Although I think
So
it's very hard for us to go border.
is there an
Oh,
Objective
mhm.
C mode for Emacs?
There is.
Um,
Where?
Oh, Melpa.
Yeah, but I'm trying to find it. Do I need to? Do I need to? What is the?
Object-C. Try Object-C.
Okay,
Object-C.
package install obgc.
and by the way, we're definitely not going over
No.
100 opcodes if we just follow the paper to begin with, because the paper has 5 bit opcodes and it doesn't use every one of them. So I think there's like 28 instructions or something in the
Yeah, that's not
paper.
too. That's not a lot. That's not too big of a list. Which one of these, Magit?
None, actually. Just like Object-C, like Control Q, Control G, sorry. Um,
Do I need to
Meta X,
refresh?
Object-C, Object-C, just type Object-C. Oh, there it is, man. You're just crazy.
Well, but why is my indentation completely fucked?
Oh, do you have LSP to begin with?
Not. No, because I didn't open Emacs from the terminal.
So, okay.
But why
Maybe.
is the indentation crap? That's what I don't understand. Like only the first one is indenting. I don't understand stuff. But okay. Let's go then. Let's go to the paper. So the first one is OPPC, PC at, right?
And it's PC fetch. Basically, it fetches the next word that's pointed at by the program counter.
Look at that though. I don't understand what's happening.
Yeah,
Uh,
that's messed up.
okay, next one is gonna be jump. Oops. I'm gonna fix that later.
I mean, I don't think we need to save bytes here, right? Just type jump, man. Please, man. One of the things I hate to abbreviate these words like it's the 80s. Just stop.
We do have the memory. Buy more memory.
I'm not asking for you to do Java name, but man, just type the word, please.
Wait. Oh, this is calling a subroutine. Where are we gonna call system calls, Marinho?
Uh, I think there might be an instruction for that described later in the paper. Uh, but I don't remember. There might be a separate paper about that actually.
About the system calls?
Yeah, like there's a follow-up paper about improving system call performance in a stack machine because uh, apparently you can do some tricks to save on the context switch overhead.
Mm, that's kind of weird. Uh, okay, let's go then. So, okay, so the first one is when the OP is PC fetch. Wait, so this paper does not address a very naive way to do system calls?
I think the way it does, like the in the follow-up, like because this paper is specifically about the machine architecture, and then I think if my memory doesn't fail me, the follow-up paper introduces a specific instruction just to do system calls, and it's basically like a trap instruction. I don't think that's the exact name, but the idea is when you're in user mode, it traps and calls into the OS. And when you execute the same instruction in the OS, it goes back to user mode, basically.
Ah, okay, so there are different modes to do a system call.
Man, I literally heard crap instructions.
Crap. Yeah, I didn't enunciate it properly.
That was awesome. Uh, okay, so I'm actually curious. Okay, so the PC one. So fetch next group of instructions into ISR. I'm understanding that ISR is like a register. Is that
Yes,
correct?
it's a register, and it's literally the instruction register, basically.
So my understanding is that differently than oh, this is a typo. Differently than A and R, they don't this is a register that does not have a special place in the
Modern world.
like return stack, top of the return stack or something like that. Is that right?
Yeah, actually, if you there's an optimization that's done later down in the paper for code density that introduces a third stack, or to be more precise, it makes the return stack wider. And then the ISR is basically like a paired register with the top of the return stack, the R register, because um, the R register holds the return addresses when you call a function, right?
Mm-hmm.
And the ISR is basically a buffer of the word you are currently executing. So like a word has a bunch of instructions inside of it. Uh, you fetch the word, it goes into the ISR, you execute the first instruction, you shift the word over, you execute the next
Oh, so
one,
the
and you do that
ISR is the temporary buffer to handle multiple opcodes in a single word that you mentioned before.
yes, yes, that's exactly it.
Okay, I don't think like I understand the optimization that you said, like ISR lives with alongside the A register, but I think that's not going to
Y-
be the case for our first implementation. What we could do is actually use the map, right? Because I don't think we are using the map. Registers, registers. We are using the map actually.
We are. Um,
Okay, so we need to do something like that. So the first thing is to detect if there is an ISR register. and if there is an ISR register there, we need to push something into that value in the map. That's what we need to
Um,
do.
yeah, so we actually have to use two registers for this instruction. We have to look at the program counter to see what's the next word that we have to execute.
That makes sense. That makes a lot of sense. So right, so then we are basically enhancing the amount of registers that we have. We have the PC, we have A, we have R. For now, I'm gonna do the very naive and ugly way. Later on, we can make it pretty. So let's see if we have PC, right? So attempting to read value. Are we reading from PC actually?
Yes, we have to read the program counter. We have to, it will contain a number, a memory address, more specifically. And then we have to read the word at that address and put its value in the ISR.
Oh, okay. Okay. So we first check if there is uh, um, something, if there is a PC register in the computer, because otherwise you need to buy more hardware. Uh,
Basic.
then we're gonna pick the value out of the PC. We're gonna pick the value out of the PC, and then we actually gonna think it's smarter to first check if there is an ISR first. So is there an ISR? If there is, so let's remove that from there.
I
There.
mean, we're going to assign a value to the ISR right after this, so I don't see why we have to do the check because it will be overwritten anyways.
I don't understand what you're saying. If there
Right?
isn't
We're going
a
to,
register, can we just? Are we doing that?
I mean, it's a map, right? You can just add a key to it. I don't see what's the problem.
Yeah, that
Yeah, but are we
that
are we
makes
doing that in
sense.
other cases? I don't think we are doing
Pretty
that.
sure we are.
I really don't think we are doing that. Really don't think we're doing that. Look,
I mean,
this is
I
pushing to
mean,
A, right? So maybe A is not there, and we are checking first. No, this is not
I
pushing to A
guess,
actually. This is pushing to the data stack. Ah.
yeah, then,
Oh, it's like
yeah,
this.
the
It is,
log.
oh, you're right. You're right. We don't need to check. We don't need to check when writing. So let's go down there. Okay, that's a little weird though. So in some cases we give you hardware for free.
Oh, it's just fake hardware.
It spontaneously starts existing. That's it. It's like
ISR.
it's not it's not there in one moment, and then the next moment it suddenly decides to exist. So it does.
Yeah, so
Yeah,
it's it's
I
it's
think
a
of
little
this as
weird.
an emulator, right? This is fake.
Yeah, I understand that. I really do. Oh, we can try actually to put this in a try catch. That's actually better. So let's try to catch from
Wait, to
this.
catch what?
Oh, but the find enumerator doesn't do that for us. Okay, so that's it. That's the implementation. So let's go line by line here. So we first check if there is a PC register. If there is a PC register, we get the value out of that and push into a maybe non-existent ISR register. Or
Just one
We
second. Just one thing. The PC fetch. It says there on the operation on the paper. Fetch next group of instructions into SOR.
yeah,
Sorry, ISR.
yeah.
yes.
How? What is the group of instructions like?
There are
Is it a?
four instructions per word, if I remember Marinho
Um,
saying.
uh, act- Actually, in the architecture in the paper, there are six instructions per
Six,
word.
sorry.
For our
Oh, it's because it's five
implementation,
bits each one, right?
yes, it's because it's 5 bits and the machine is 32-bit, has 32-bit words. If it fetches an entire word, the word contains multiple instructions. It puts that in a register, which is basically a buffer for what's going to do next.
Yeah.
And then it executes the instructions in the buffer, which is the ISR, until it runs out, and then it fetches the next word and continues executing like that.
Can you put a comment for that there
Sure.
after
So
the if? I think it's better.
after the if, okay. So each
I mean, on line 9. That's what I meant. Before the code and after the if for the
before the
99.
code and after the if. Here?
No, no, line 99, man.
Oh, here. Sorry.
Yes.
So each word contains 6 instructions of 5 bits each. Um, there, and then we're also gonna say PC puts the word into a temporary buffer called ISR. Okay, okay,
Okay,
okay.
what's the purpose of ISR? Like, I
It
get it,
holds
it's putting stuff there, but why?
because then we don't have to fetch the same word again just to shift over 5 bits to execute the next instruction.
Yeah, because do you agree that Mageta
Oh, I
that
see, I see, I see. So you're just moving them. I see, because you still didn't process them, right?
yes,
So you're
exactly.
okay.
This is a fetching process. This is a fetching process. Next one. But do you see that? Do you see what this means, right? You already see the masks and you already see the shifts, right?
That's beautiful.
So we're gonna definitely do that. Next one. So it's jump.
Oh, the PC fetch also has to increment the program counter afterwards. Otherwise, it's going to keep executing the same instruction the same instruction word over and over again. That's
Mm.
Oh,
not
that makes
correct.
total sense. So let's actually do that. So this is gonna be value of PC plus one. No, no, this is not what we want actually, right? This is the value that
Uh,
PC contains. That's not
no,
what we
it's
want.
no, that's right. It's value of PC plus one. That's correct. But then on the for key, we have to change it to PC instead of ISR.
No, yeah, but my understanding is that if you do this, correct me if I'm wrong here. If you do this, what you're actually saying is to the PC to grab the value that is contained within itself, which is the 6 instructions, and increment that by one.
No, no, no. The instructions go into the ISR. The PC is the program counter.
No, I understand that,
Right?
but doing value of PC plus this is a word, right? This is 6 instructions. Do you agree?
Value of PC register. No, that's the current program counter, the address that it points to. Oh, and then the set object on the line after that is actually wrong. Instead of
That's wrong
putting
then.
the value, yeah, instead of putting the value of PC in the ISR, we have to go into RAM. We have to fetch whatever is pointed at by the program counter. So
Uh, uh-huh.
yeah, and that's the new value of the ISR. That's
That makes sense. That makes a lot of sense.
I need to put a parent. Oh no, it's a pointer. Never mind.
Yeah. Okay, so let's go to jump. Jumping. Okay, so what jump does? It does an unconditional jump. So where it's gonna pick the address to jump.
oh, that's the fun part. The address is actually the next word that we would have fetched.
Wait, the next word? How does that work? So you're gonna
So
so you're gonna do
so
PC
like
plus one?
no, just PC because what happens is you fetch the instructions under the program counter, right? And then you increment the PC so it points to the next word. And then you start executing the instructions. And if the instruction you're executing happens to be a jump, what it does is it looks at the PC, fetches whatever word is pointed by that. That word is the address we are jumping to. So it's like an instruction
Ah,
argument, kind of.
okay, so it's basically this, but to PC itself.
Yeah, we get the value. Yes, that is correct.
Okay, so jumping you basically have to put the address before having the jump instruction, which makes sense.
It's actually after.
It's actually after.
Because you fetch the instructions, there will be a jump right there in the middle, right? Of this instruction cluster, I guess you could call, block, whatever. And then the jump will look at the program counter, but since we fetched the instructions first, the program counter now points at the next word. So the word after the word
Oh,
contains,
okay, okay. I forgot we were doing this before. Okay.
yeah. So the first word contains the jump instruction, the next word contains the jump address.
Yeah. Yeah. And then we are basically going to the address in memory, grabbing the value out of that and putting that to PC.
Yes, that's how
Okay.
we do a jump.
Okay. Okay. Okay,
Then
next.
jump zero, yeah, jump zero is the same thing, except it looks at the top of the data stack, and it only does the jump if the value in the top of the data stack is 0.
Wait, I didn't follow that because I was purposely adding, wasting more memory because of Magit.
So
Go ahead.
yeah, that's jump zero is a conditional jump. It looks at the top of the data stack. If the value
Mm,
is a 0, then it does the normal jump. Otherwise, it just
pops the stack.
it it pops the stack, and also it has to increment the program counter as well.
Okay, so we already did this before. I have no data. Grabbing from data here. This try catch. Oh wait, we always pop, right?
We always pop, yes.
Okay, so this is actually the one. So let's go. So first thing is, well, we need to check if you have PC anyway. So the next thing that we're gonna do is pop. So this is gonna be like popped value.
Yeah,
Yeah,
so you
popped
pop
value.
the stack.
Sure.
If
We
the
already,
value you pop is 0, then you do the same thing as a normal jump. Otherwise, you just increment the program counter.
well, we're gonna have to do the casting again. I'm gonna assume is like this.
Uh,
I
wait,
hope
the
Mageta, I
cast.
hope Mageta helps me
Wait, wait, the casting for what?
for an integer.
Yes. If it's in a variable, yes.
Okay, so it's
For a
gonna.
pointer, right?
So if it's equal to 0,
Yeah, which needs to be also inside the. I
also
don't think that
what?
needs to be a reference. Yeah.
Is this the way, Mageta?
For a literal, yes, I
Okay.
think so.
Okay, if this is equal to 0, then we jump, right?
And we jump. We do the
Okay,
same thing as a normal jump.
okay, then we jump.
That depends on the function. I think that is true. Doesn't take a thing. Oh no, man! The popped value is a ID, right? So you need
Yes,
to put a at on before the 0.
like this.
I think I'm not sure if you need parentheses. I think it's a literal, so no, probably no.
Okay, we're gonna discover pretty soon anyway. So then, if it isn't, we just increment the program counter.
Yes, because the idea is we did a conditional jump. We didn't take the jump, but then the program counter is currently pointing at an address, and we don't want that because we will continue executing instructions, right? And if we don't increment after failing the conditional jump, we will fetch the address and try to execute that as instructions, and that's not good. So
Yeah.
that's why you have to increment the PC.
Okay. No, that makes sense. That makes sense. Next one is jump plus. Jump if top of the stack is positive. Okay, so it's basically the same piece of code.
Basically, yes.
But instead of comparing to 0, I'm going to compare if it's greater than 0.
Yes.
I don't have LSP. Mageta, do we have is greater than?
Let me look. Objective C is greater than. Probably do. But in that case, you can just do the. Yes, you do. Is greater than.
Did I type it right?
Let me see. How did you type?
Here.
Yes. No, no. A instead of N. Yeah.
greater than 0. Okay, so if it is, we do the same. If it isn't, we just increment the PC. Call a subroutine. That's very interesting. So what does that mean?
It's basically the same thing as a jump, except except we push the current program counter into the return stack instead of just forgetting it.
Oh, so we okay, so we basically do a push into the return stack.
Yes.
Uh, Here. I might change. I'm not changing, guys. I'm not changing. Are you okay? So jumping 0. This is gonna be jumping plus.
I gotta think of a way to organize this code after we're done.
Yeah. I don't really think there's a well. There is a way. We can just
Like
make
it's,
smaller
I
functions out of this.
mean, yeah, that's what I was thinking.
The next one is gonna be. This is the call. So call. The log's gonna be calling. So good. Okay, so it's basically the same thing, but instead of just jumping there, we also need to save. Oops. We also need to save. So push.
After we're
Yeah.
done, I think making a procedural language for this would be a good idea.
What do you mean procedural language?
Like basic, like you do a very basic
After we are done with control
Actually,
flow,
compiler.
we only need the parser, Magit. We already have the language.
No, yeah, honest. No, no, I'm saying make a basic and compile to this opcodes.
so you want to write a compiler that turns basic into forth?
Yes,
Is that
yes.
Is
That's,
basic like the one with the classes, or this
no,
is Visual Basic? I'm
basic.
confusing.
Yeah, that's Visual Basic .NET, which is different from Visual Basic, by the way.
that's crazy?
Okay, okay. So anyway, let's go back here. So what do I need to push to the return stack?
The
My
value of the program counter,
the value of
value
the
of PC.
program value of PC. Okay.
Yeah, to push we don't need the parameter.
Yeah.
And actually, calling is unconditional, so you don't need
Oh,
the.
this is gonna be so much more messier because we're gonna add. Oh, that's a thing that I want to talk to you about, Magita. So I was
I
talking
think I
to.
noticed a bug, a problem. Can you go back to the code?
Wait, before we do that, I want to talk to you about this. So I was talking to Marinho, and I think that having an infinite stack for both
Yeah.
stacks is kind of like too Nutella for the seriousness of making a VM.
What do you mean, man? What do you mean?
Well, because if you think about it, it's kind of unreasonable to think that you have an infinite amount of memory, right?
Well,
It's actually
yes, but
no,
it,
no. Actually, that's not even saying you have an infinite amount of memory. It's actually saying you have an infinitely large processor with an infinite amount of registers.
yeah, which is worse, I guess.
Yeah, exactly. So I'm just mentioning this because as soon as we add this issue, every single push will be a try catch. So prepare yourself for that. Go on,
Yeah,
Maggie.
we.
Maggie, you said that you found a bug.
No, I was looking at the object at index. So I think, let me see here. So that thing takes an index, which is a NSU integer. So I think it doesn't need to be a class. Well, we will discover. Probably you need the pointer there, but I don't think so.
Okay. Last one before
And
testing is the return.
yeah, the call, you have to make it unconditional. It's currently weird.
By the
The
way, we're
call.
reading this behavior on the paper. I'm looking here and I don't find it.
No, we are not reading from the paper. I think we are reading from Marinho's mind.
It's
Okay,
from memory. I
well,
already read the
photography.
paper a while back, and I kind of have this thing loaded in my brain because
I
it's
see.
very close to my heart, and also because it's relevant to FAO, which is my project that I'm working on. And so, because
Okay.
I always keep in mind, it's
I
just
was planning to read it yesterday, to be completely honest. But then I screwed up my sleeping schedule on Sunday, which means that I didn't sleep from Sunday to Monday, and I finished my day and I just died. So that's why I didn't read
Well, hopefully you didn't die, right? That's why you're here.
it. Like I finished my work and I just completely fainted. That was that was. But I was planning to read the paper and do some other things, but I just couldn't. You can ask Josué later, Marinho, about yesterday. That was it was wild because both me and him we were both with bad sleeping times, and
I see.
the issue that we were working on was completely like not good if you're not 100%.
I see.
Okay, so you said about that the calling is conditional. What do you mean? Oh, it is
Uh,
conditional. We are done.
uh, yeah, you base the op call on on the conditional jumps. That's not correct. You have to base
Okay,
it
so we
on
actually don't need
the.
to pop from the data stack then, right?
No, we don't.
Okay, so that means we can get rid of the try catch, which is
Um,
good.
I guess
Yeah,
you can.
wait,
Yeah.
can we?
Yeah, because it's not gonna
Uh,
pop.
yes, but let me see.
There it
Yeah, I
is.
don't think so. Oh, wait, just a sec.
Oh, the names are also wrong. We need to change these names later. This is not a Stack
Yeah,
Underflow.
those stack underflow things they have to become something else
Yeah,
later.
register something. Lack of register absence.
But I have a feeling. I mean, since no in Objective C is basically zero, and zero is a valid value for a register, right? Because it's an integer. I have a suspicion that all those throws will eventually disappear, but let's keep them there for now, just
I don't know
for.
how they're gonna disappear. This is basically checking if you loaded the machine with the
But if you
registers.
load the machine, you expect the registers to initialize to zero, right? Or something sensible like that.
No. This is actually checking the presence, man. This is checking
Okay.
the presence of them. This is not checking if they have the zero value. This is checking if
But if
they are in
Oh yeah,
there.
this is yeah, this is that was the whole problem, right? That's why we did this.
Yeah. So what that means is that you can argue that we are making the VM, so we are sure that we're gonna have the registers, right? Because
yeah,
it doesn't make sense to assume that they will not be there because we have total control over that.
Just to refresh everyone's mind, we did this function because uh, there was no difference between getting a thing from a key that doesn't exist and it spitting null and zero.
No,
So
that's
we
it.
did
No,
the
but that's
thing
exactly what Marinho was talking about, Mageta. What he's saying is that at some point we're probably gonna get rid of all of these ifs that check for the existence of a register because we
because
have
we're
total
gonna just
control of the VM.
populate registers.
Yeah, we're gonna populate because the user cannot have control over that, right?
Yeah, yeah.
We have control over that. So we just made them because of our very strong correct by construction approach. But in practice, this will never happen because nobody will ever use Chime without the registers.
Oh, why
uh,
not, man? Why not?
What do you mean?
Can perfectly use it without P. No.
Returning. So returning, what we're gonna do? We're gonna
you
grab
pop the
something from the
return.
return stack and put that into
You
the
pop the
PC.
Yes, that's exactly right. I didn't even have to tell you what to do. You already knew.
Nice. Okay, so if we're gonna do a pop, we definitely need the try catch. So we're gonna pop from the return stack,
Mhm.
and we're gonna put that back
In the PC.
to the PC.
Just one sec. Why are you checking if it's greater than zero?
We are not. I'm gonna
Because
remove this thing.
Okay,
if
okay.
This is a
it
copy pasted code.
All right.
copy pasted from a
Uh,
conditional jump. Yeah.
okay, so it's gonna be just this. This if is gonna disappear,
Mm-hmm.
and then instead of that, it's gonna be popped value, and that's pretty
Popped
much it.
value.
It's mistyped, by the way.
It's
It's
Pop,
mistyped.
mistyped.
Yes.
It's popped value.
pop, poop. Mm.
Yeah.
Okay. Okay.
If he
That's
actually meant if he actually meant popped value, it would need to have a double P in the middle.
Oh
no.
yeah,
Thank you.
it's CVC, consonant
Replace
vowel.
string popped value. Another P you said, right? Like this?
Yes. Yes.
Okay, so I think we are done. We can test it to see if it works. Actually, I'm tempted to just make the parser because it's just separating by spaces, and then we can make a program.
Yeah, I was thinking about that.
Let's do that then. Do you want to drive
Let's
now,
do.
Magetta?
I can. Let me go to macOS, man. Just give me a
Sure.
second. Let me quit here.
Let me. Yes, I do want to save that. Thank you. Okay, so this is basically adding the. Let's actually try to be a little bit more reasonable. So contracts
We
G.
may have to tweak. We actually have an execution loop already.
No,
I
we
think
do
we
have the
do.
execution loop. So, but I think we're gonna have to manually like put instruction by instruction using the push, and
Yeah,
we'll.
no, actually, we will probably have to tweak the instruction loop because right now it's reading from the data stack, right? It should read from RAM instead.
Oh, you're totally right. Let's do that when Magetta is back. So what do we have in here? Okay, so what is this doing? Oh no, this is doing implementation. Okay, so let's first commit this. So this is adding flow control opcodes. Next one,
By the way, we already have an instruction to move a value to the return stack, right? I think we
return a
did
value to the
that
what?
like to move a value from the data stack to the return stack. We did that last time, right?
You said remove from data and push to return?
Yes, we
Yes,
already
yes,
have that,
yes.
right? That means we already have higher order functions. How neat is that?
I have no idea what you're talking about, but I believe you. Adding, add memory, RAM, RAM to our VM computer. Uh,
Because like
implement.
if you have a function pointer as an argument in your data stack, how do you call it? You just push it into the return stack and then return. That's it.
Wait, repeat the problem? Actually,
If
wait for me to finish this commit message because I think I'm gonna need 100% attention to follow you.
okay, that's fair.
Implement new control flow instructions. And let's push that. Oh, I pushed into master. Oh.
Oh, that's
Okay,
bad.
yeah, that's very bad. And I apologize. I apologize.
Buford for updating at the most precious time.
I did BS,
Hello.
Magetta.
What?
I forgot to make a branchman.
Oh, wait. Where did you do? On master?
Yeah,
Did you push already?
yeah.
Okay, so never mind then.
No, no, no. But now, pick when you pick the
No,
code,
there's a
check
way
out
to
from it.
fix. No, there's a way to fix. You can check out, make another branch, and then you roll back master, and then you merge again.
That's okay. But I think for only 3 commits, I don't think I broke
Ah,
the
that's
world.
fine. Yeah, no,
No,
that's
but
fine.
let's not make that common practice. That's what I'm saying.
Yeah,
Anyway,
yeah, yeah.
uh,
We should block actually. Let's do that now.
yeah, I know how. I think
Uh,
I remember how to block. Because I did this in Racket Tower. You cannot push to Racket Tower masters. I think.
do I have permissions to edit
You
this
are an
node
admin. You should be able to.
We're
branches?
safe because we don't have
Here,
CD yet.
master.
Yeah, we need to add CI. I don't know about CD, but we need to add CI.
Let's not require approval. That's dumb.
In Racket Tower,
I
you
mean,
require approval actually.
okay, let's require one approval.
Yeah, at least one.
Allow force push.
Oh, Magetta, fun
Hmm?
fact. Our VM with the batch of instructions that Lemo just wrote already supports calling a function as an argument.
High order functions basically.
Why exactly? I didn't get why.
Yeah. Also.
Because yeah, because last time one of the instructions we implemented takes a value from the data stack and moves
Hmm.
it to the return stack, right?
Right.
And just now we implemented the return instruction. So if you get a function pointer as an argument, you can move it to the return stack and then
Oh, I
just return.
see. I
And
see. I
you're
see.
effectively calling that function.
Mm-hmm.
Oh, I think I understand. I think I understand. So you can
Yeah. The only
wait.
thing is that you're not passing the function as a value, right? It's just a reference for it. That's the way to think about it, I think.
Yeah, we don't have closures. We just have a pointer to a raw code address.
Wait, but say again the last part. You to call the function that you are receiving, because I think I understand how you pass it as an argument. You just pick the reference for it and you put that uh,
In the
you put
data stack.
in the data stack, and then when you want to call it from the higher order function, you just call
You
it, no?
just Yeah, you just move the function to the function address to the return stack with
Mm-hmm.
the instruction we implemented
Oh,
last
I
time.
see, I see, I see, I see.
And then you follow up with a return, and you will return into the function that you just pushed to the return stack.
Yeah, I see, I see, I see. Don't
This
forget to
one
make a
thing,
branch, Maggot.
this is incredibly big A, but that's fun. Uh, so parsing. Yeah, it's funny that you left the best part for me, right?
To be fair, this is only splitting by spaces, right? This is
Yeah,
not very big, like context free, whatever the crap. This is
uh,
literally splitting by spaces. Actually, we need to be
really.
clever because it's not spaces, it needs to be white spaces.
Yeah,
Okay,
it can be
let's,
tabs, it can be new lines,
Yeah.
whatever.
yeah. So let's make. Ooh, you did it. Oh man, you changed the organization in the in the directory, right? But not in the thing.
Oh, you need
Let's
to
say
do
the
that
thing in itself.
twice?
Yes, sir.
Okay, my
So
bad. Ah.
just open here. Chime. Yeah. So you see, I need to now move things myself. That's fine. Uh,
No, but I apologize, I didn't know.
no, no. There's no way you could do this anyway. It's just oh, new group. All right. So, but this will create a folder. How do I undo that? Okay, these things don't have no reference. Okay, so it is attached to the folder. It's not like Visual Studio, which is cringe.
It is cringe. The guy using Xcode.
I think it's this. There is already one. Create groups, create folder references. That's it. There we go. Okay, so
Nice.
I don't think it even needs to be called include, by the way. But well, so let's just
Commander
make another one. Yeah.
Commander
Wait,
just
wait,
asked
wait.
what we're working on.
Yeah, you can answer him that we are working on our stack-based virtual machine. I have a suggestion first, Magita. Before we do the
Mhm.
parser, let's actually fix the evaluation loop.
Man,
So
why
go.
are you keeping this? Just remove this graph.
I'm not keeping it.
Uh,
Well, I am keeping because I'm not actively deleting them, but I'm not doing anything about them.
it's
Uh,
just that when you create an Xcode, it comes with this.
before we continue, let's fix the evaluation loop because Marin said something important. It is
No, what is
not
it?
anymore because the data stack is empty. It's because the memory is empty, right, Marin?
Actually, it's just a while through. Like you have the RAM, which is basically a big array that we're probably going to initialize to 0, right?
Yeah,
And then the program will be in RAM,
yeah.
and so we just have to execute until we halt, basically. So while through, and then instead of fetching the instructions from the data stack, we just
Wait.
we just
Start
fetch
from the
whatever
beginning
is at
because I lost
address
it.
0.
I can repeat. Go to the
Okay.
beginning of the evaluation loop with a while something something. Change that to while true. It's gonna be an
So
infinite loop that
okay.
we're gonna have to actively delete. And then
Yeah,
instead
at
of
some point,
popping from the data stack, you're gonna actually read the you're gonna grab the you have to grab PC, right, Marin?
Oh, I see.
yeah, we
I
have
see. I see.
to yeah, we have to fetch PC. We'll probably just initialize to 0, so it's I don't know, it may be a bit clearer to just fetch whatever is at address 0, because if we assume that PC will be initialized to 0, that's the next thing we're gonna fetch, right? So
Cringe. So
Isn't there a
was this?
configuration like that you can put add the include
I
as a
think I
dash
can
I?
do it here. Libraries. Yes. You see, there's nothing here. I need to add myself.
Sad.
Uh, yes, that is awesome.
Wait, but I need to ask Marinho again. Marinho, so you are assuming that we always gonna put the beginning of the program at the beginning of the memory, right?
Yeah, like because think about it. If we assume that everything is initialized to zero, that means the program counter is also initialized to zero, right?
I think that's okay, but I think I would be more. It would be more safe to just always pop from the program counter, because if we ever decide to change from from the beginning to something else, we have that flexibility.
That's fair. Oh, also, we may have to move some of the instructions around in the enum because an important thing that the paper does is that the PC fetch instruction is opcode 0. That's relevant to how the machine works.
Oh, the order does matter.
Yeah, for that particular instruction, it does. For everything else, I don't think it does
Okay, so
actually.
just swap the
Man, I'm
blocks.
gonna do something very cursed, but
No,
something that we
no,
both can compile.
no.
Man, it's just that I cannot compile like this, and I don't want to mess with this now. And you can compile like this as well. You just need to put the path there.
Why there does it need to be headers and not include though?
No, it doesn't need to be. It's just that it's not really include. Otherwise, I would be adding include. It's better to just add a path here. Looks less disgusting. And still failed. Why? Oh, okay. Headers.
I'm so fucking sad, man.
That's fine. We will fix it later. We need the nixers to fix it. Okay, we have some bugs here.
Okay, so this is
Makes
not how you do
sense.
the sum apparently. Oh, you need
Your
to
casting.
dereference because this is a pointer. So put the at.
So this is a ns integer.
You can also do that, but that's gonna be the automatic dereferencing.
Just one thing, like the value in the PC, what is it? Is it an integer?
Mm, it is whatever the registers are made of. I don't remember what the registers are made of.
Well,
You,
bytes, right?
no. How we were modeling. You need to go to vm.h and see how the registers are being modeled.
vm.h. H is not here.
I don't recall at all. The registers is an NS map table.
Okay, so
I,
on the initialization, we gotta see.
yeah, we gotta see the initialization, I guess. No, it's
Nothing.
also not telling us. So actually, I think we can choose. So it can be anything.
Yeah. Oh,
So
it's not certainly not the strict typing. It's so.
oh, actually, we can. I think it's gonna be an S integer because if you go to the VM implementation, the ones that we did before, like the last session, I think we are pushing NS integers because the stack is NS integers, right?
Actually,
Yeah.
I don't know. Let me see. Oh, yeah, we're pushing. Okay, so as long as we're doing from this, yes, right? Because
I
these
think
are
it's an S
integers.
integer then.
Yeah.
It can be anything because we are using pointers everywhere, so it doesn't really matter.
Yeah, it's like a void star.
Yeah, it's
So,
like a void star. Okay,
which
can we
is,
build, or do we still have
uh,
problems there?
yeah, I need to fix these issues now.
No. But that's the
So
thing.
this
I think that the
is
problem
a
is not casting on
lambda.
line 103. This needs to be ID.
No,
Yeah, I
no,
think
no.
we need to put
The
an at
problem.
there.
Wait, the problem is the typing. An S integer is long, blah blah blah. It's disallowed. So this is the casting issue.
Yeah, so I wouldn't cast, but I would put at the
Well, we need to
beginning.
cast.
Don't we just need to dereference? I'm confused.
Yes, because if we do like this is a pointer, and then we're trying to do pointer plus one,
Yeah,
which
but
is
then
an
can't you
address.
put the at in the beginning of the value?
That's not dereferencing. That is referencing. Like this, for example, this is a normal. This is just a literal.
Yeah.
This is a pointer.
Oh, okay. So I got it completely wrong. So how do you dereference?
So we did it here actually, uh, or I hope we did.
I don't think we did. I think we
I think we
tried
removed.
and then we
We removed.
surrendered.
No, it was working. We just removed it at some point.
I think
Yeah,
it
next
never
time.
worked, and then we surrendered to use
It
IDs
did.
instead of
It did.
opcodes.
I remember working. So we need to dereference. Man, we can cast this garbage. Let me just think here. It is object for key. That is right. I think we can just do an SU integer. Like we just gotta pick the correct typing. That's the main problem. These things we're pushing here, they come from the data stack, which is what?
It's also we also don't know because they are also pointers.
They really
Uh,
should be all integers, I guess.
No. Yeah, because I think those are the classes, right? Because I know that the enumerators, they are this. I hope. Yes, they are this. So I thought we were using the same, also known as unsigned long, true ID nullable. Ah, man, how do we do that?
the funny thing is
Let
that
me
I think this
think.
was compiling before, no?
No, it wasn't.
No, you didn't test with the previous stack manipulations ones?
I'll roll back to what it was. It was like this,
No, no,
which
no,
is
no, no,
wrong.
no, not before this one. I'm talking about before we added those instructions.
Before we added those instructions.
Yeah, because from
You
line
mean
Oh,
98
before
these,
the
onwards.
all of these. Yes,
Yeah.
before all of these that we added, it was working. Like
Ah, okay,
until the
okay.
over.
But it never actually mattered what were them because they are all IDs. Now it's the
Yeah.
first instruction that actually matters because we need to do
So I think
operations
we
on top
can
of
do
them.
this. Maybe we can do this. Oh man, that's gonna be very cringe, but we can probably do this.
I have no idea what you're
Uh,
doing, my man.
because this is a number, right? So
Yeah.
let me cast this to NS number. Don't know what that is, but it's. I hope it's a number.
Let's
we
hope.
shall hope. Let's
Yeah,
hope.
that's all.
Let's
That's all we
hope.
can do. NS number, and then inside the number. Man, why is this indentation screwed up?
Yeah, I have no idea. It's what I
Oh,
said. My Emacs is completely broken.
what? Oh man, this is wrong.
What?
Wait. What the heck?
What? Uh,
This. Wait. This closes this, right?
oh,
And
there is
then
we are
this,
lacking one. I no, we're not lacking one actually.
this. That was wrong. Okay, it's
Okay.
just the indentation though.
Okay.
Okay. But let's focus here. So if this we cannot cast statically allocated, let's see.
I'm
Insert a
starting to get
pointer.
worried. Can't we cast IDs to numbers?
It has to be an NS integer, I think, not an NS number.
Yes, I think the NS number is the other one.
Objective C. Magetta.
Because
You're gonna find the most autistic tutorials on this, by the way. Diga?
Magetta.
Yes?
Marinho asked in the chat, not this chat, but in the chat, why are we doing it in Objective C?
Oh, we don't know either.
No, we do
Tell him
know.
that.
I know at least one reason.
It's me who is the culprit.
No, no, no. It's not. Well, it is
And,
because of you, but not because of Big A or anything like that.
well,
It is
really?
because Magetta wants to code some C, but not raw C.
Because I'm bored, we see.
So then there's the middle ground of using Objective C and C++, but C++ is very, very much bigger than Objective C.
Don't know
that's
if that's
fair.
the reason though, but let's
That
go with
was a
that.
reason. That was a reason that you said.
Uh, man, like on these docs, I remember seeing it. There was a thing to add, but like because we got a bit, I know a way to fix this, which is you just use the method, right? You cast the type, which is permissible, and then here we use uh
Can't
the
you just
value
do
as
plus one?
sorry.
Like, can't you just do plus one if NS integer is basically just a long?
I think we can do this. No, we can't. Add. I mean, we can do probably we can do this. Oh, it was like this, right? But this is
Well,
a
can
pointer.
you check to
There.
me?
So this is a pointer now.
Wait, but what is this doing? This is a
Well,
pointer to a number
it
plus value
It's
1.
picking, it's dereferencing this garbage and then
Sure.
picking this other garbage and adding with the value of
And then
it,
making a
and then
reference out
make
of
a
that.
pointer again to set the object.
Okay, okay, I see.
This works because this already gives you a ID,
Yeah,
objective type. So
yeah. Okay, try to build then.
yeah, I did. It's probably the
Which
same
one is
issue.
failing?
Value of PC. This shouldn't fail though. Let me
This
see.
isn't a writing problem.
Oh, it's
Compatible type. Okay, so let's cast here an SU integer. Actually, it shouldn't be a U integer, right? Because you can have negative numbers.
You can have negative numbers.
Where's
can
the?
have them.
Oh, I did with that. Okay, not that ISO. Maybe just a bit.
Oh, there's also a second reason because apparently Objective-C has a small talk influence.
Yeah,
That's another reason.
man, I'm very confused with this indentation now. This is
No, the
screwing up
indentation
the
is
code.
completely fucked. The indentation completely fucked the understanding. There's no way. Well, I can tell that 122 is completely not indented correctly.
Yeah, can I format this garbage?
Refactor?
Apparently no.
No. Wait, this is
Uh,
an IDE. They don't have a format button. Are you guys
format.
joking?
They do. I
Oh,
just
they,
don't
they
know
even
what
they
it's
even
for.
tell you where it is because they assume you are an idiot.
Oh, but it's the text elements, macOS. Format, substitution, spelling,
So
grammar.
useless then.
Yeah, they don't.
So
Man,
freaking useless.
or unless they call it something else, which would be very
No, but
stupid
that's
for
no
an
problem.
ID.
I can help you with that. So line 122, that's where all the garbage starts. Do a
122.
tab
Yes.
there.
Wait a second. What? Why the try have
There
this on
is
the
an
try?
if inside a try. There is an if inside a try. That's correct.
So wait. Let's do this. So this.
This, yes. Then that, yes. All of these will also be indented according to the if.
Yes. Diff.
That as well.
Here.
That as
And this.
well.
Okay, it's smart and it picks it up. At
Okay,
least
so
that.
now we have the catch. The catch is indented with the try.
Here.
And
And
then
then
the
this goes
else
here.
needs to be indented with the if, actually.
So this closes the
The
catch.
catch, yeah. And then the else needs to be indented with the if. And now it's
There.
correct.
I hope.
Oh, the line 118 is also, yeah. Okay, now we
Okay,
need
that's
to do
better.
the...
So the same issue. Here.
Oh, no, 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 it's not, it's also that. But the line 123, you need to move that upwards.
123.
You need
What?
to put that before the if.
Oh, this.
Yeah, this entire line, put that before the if.
I have my Emacs stuff. It's just annoying.
Yeah, I understand the pain. Okay, is it
Okay,
complaining
now it
still?
works. Doesn't seem like it. It's complaining here though. Value of PC.
The indentation is also completely fucked. There. Line
So
112, we need a tab.
man, I think this is unsafe to keep doing this. But I think since we're dealing with PC, they can't go negative, can it? I don't think it makes sense.
No, it can't.
So I think in this case, it kind of makes sense to because it doesn't matter the type, right? It's just a pointer.
Yeah,
So
I agree, but it's very, very uncomfortable that we need to do this sort of semantical
all right,
casting
yes, that
ourselves.
that I agree. But well, we are in C, so
No, but in C you don't have to do that.
oh, you have void. This is the
Yeah,
void in
but
C.
as far as I can tell, we couldn't manage to make it to not use void star. That's the
Oh,
problem.
because it's using methods from the class, but if we're not using those and we were just using normal stuff, I don't think we would have the problem. But then we need to do our own like data structures and everything, which is sorry, no, not doing that.
Okay, the most fun part, Mageta says no.
Most fun part. What do you mean you're a psychopath? There's no way.
No, are you no man? You feel pleasure when you make your ADTs. Don't start.
I I don't in the least, man. I don't in the least. This goes before the
Yeah,
wait.
before the if as well.
Yeah, because it's using on the else. Makes
Yeah.
sense.
By the way, Lemus, speaking of, typecasting and things, I actually started doing a little bit of that on Sal. Like, I think it was Sunday, I think. Uh, it's not on the repo yet because I was just messing around a little bit to see how it would actually work. And I can tell you, low-level casting, trying to make that work with an actually decent type system is not fun.
Yeah, it's not fun. It
Especially
feels
when you
really
have to
wrong though.
indent. Especially when you have to indent your code. Makes things less fun.
Yeah, it's less fun. Okay, try to build now.
I still need to do the others, my sunshine.
Oh yeah, we need the casting. I forgot. Sorry. And we also need to remember to change the condition of reading to read from the PC instead of reading from the data stack.
So why is this garbage wrong? Oops.
Let me check for you. Why is this wrong? Oh, maybe because the return stack should be accepting an S integer and not an SU integer.
Ah, our push takes a thingy.
I
Ha ha
see.
ha ha ha. Funny, isn't it? Let's see. The rest here is correct.
Man, I didn't let leave the code with this indentation. Your Xcode messed it
Yeah,
up.
it did. It was Emacs, I think. The this indentation scheme on Emacs.
I think it's actually a matter of tabs versus spaces. It's biting
Probably,
us.
probably.
Okay,
We
so
can use a we can use some formatter.
line
Probably
38,
Emacs
you're
is.
gonna do the if checking if PC exists. So copy paste, try to find an if checking if PC exists. Because if PC doesn't exist, we should not do anything at all. We should break the loop actually.
Um, we can just set it to 0, maybe.
We can do
Oh,
an assert, I think.
an assert works. But your idea was not bad, Marinho. To if we don't have PC, just assume that we should go to memory zero. That that would work. And then you need to pop. No, you don't need to pop. You need
So
to.
okay, if this fails, it will halt the program. That's not the behavior we want, apparently. We want to just do the memory, right?
Yeah, yeah. So you do an if and else, and if the if is true, you just read the contents out of PC. You can also copy paste that from the other code.
Uh, I do
Value
what?
of
Say again?
PC. Try to find a value of PC. Line 108. So you
Okay.
read that,
And then,
and then you put ID opcode equals to value PC, and you don't need to cast to an S integer in this case. It can be an ID.
so this here.
Yeah, actually you can just read the PC and put that into opcode for now.
So I can comment this line.
Yeah,
So ID opcode. Oh,
and you just put the what is after the equal of the previous line. That also works.
so
Uh,
just this.
yeah, but Marinho, I have a question for you, man.
Yes?
So, as far as I understood, PC doesn't have a single instruction. It only has one instruction. It always has six instructions.
No, PC is a pointer into memory for the next instruction we are going to execute. But actually, it's not the instruction itself, it's the next word, to be more precise. And the word is much larger than an instruction. It has
Sure,
a bunch of them inside of it.
sure.
So when we fetch yeah, it's not actually an opcode. We would have to,
We're gonna have
uh,
to make a mask, right?
uh,
How does that work with the object system, by the way? Can we mask on objects? How does that work?
I didn't get it. I mean, I got the part that it doesn't make sense to be an opcode, especially on the case that we handled here, because value of PC, for example, if you're doing +1, it's not moving the address, it's moving the uh, enum in the opcode, so it's moving this order here.
Yeah, but that's the thing.
If
Yeah,
that is an
If
opcode.
if PC is actually a 32-bit, a complete fulfilled 32-bit word, we don't have a single opcode. We have 6 opcodes.
Yeah,
yeah.
it should
Actually,
be
I think the correct thing to do here is actually to
make an object, right?
we would have to make hmm, see, the opcode is actually the way to actually grab that is you have to look in the ISR, which contains the current words that we're executing,
Oh, so
and
you
we have
never
to
read from
mask.
PC then? You always read from ISR.
Yes, you read from ISR, and then the when you only read from PC when you're doing the PC fetch instruction. That's why that instruction has to be zero, because as you shift the next instructions over to execute them, eventually they will run out and you will shift in a zero,
Fuck, so we're gonna have
right?
to make a mechanism in here. Okay,
Go
so let me
No,
explain to you,
no,
Mageta.
we
on.
just have to say opcode is we have to shift the ISR by however many bits we are going to use per instruction,
Yeah.
and also mask off that many bits
Yeah,
because that's the
yeah,
opcode.
yeah. But what we need to save the ones that we the mask is removing, right? Because they are still opcodes in there.
No, man, where the shift is to remove the opcode we're executing now. Like we just save that somewhere in
Okay,
a temporary
let me make
variable.
my Mageta in the picture here. So Mageta, what we're talking about is the following. We never, to get an opcode, we never read from PC. Why?
Yeah, that
Because
part I
PC
got.
puts all the instructions into the because PC always have the next set of instructions, the next 6. What
Hmm.
we do, we put the 6 instructions into ISR, and when we are beginning the loop of the evaluation loop, we actually read from ISR. But ISR has 6 instructions, which means that we need to do a shift and a mask. Actually, depending on how we do it, no, sometimes we're going to use a mask, sometimes not, doesn't matter. But then my question to Marim is the following. Let's suppose that you read from ISR, then you do a shift and then a mask. How are we going to know that there are 5 remaining instructions? So we're going to have to count that, no?
Can't we just do
You
a man like
no, but
here's the question. Can we
that's
group those and abstract them? Because this is just a uh, high level representation of that, right? It doesn't need to be 6 loose instructions. Can we just group them
You
like
can.
with some
You can
wrapper?
you can make an abstraction to group them. But my question to Marinho is that we need a mechanism, as far as I can tell, to say that we don't have 6 anymore. We have 5. We have 4. With or without an abstraction, we're gonna have to have
but
this mechanism.
no, that's the beauty of the thing. Like because as I said, because the instruction to fetch the next instruction and advance the program counter is zero. When you do the shift, you automatically shift a zero as the
Oh,
in the slot
so that
at
we
the
read
end.
from the right to the left then, right? When you consume an instruction, you actually are putting zeros on the left side, right?
No, you're putting zeros like
Oh, it doesn't
a
matter, right?
word.
It doesn't really matter actually.
No, it doesn't. Like a word is just we break it up into a sequence of instructions, right? What matters is we read the first instruction in that sequence, either from the left or from the right, and then when we do the shift, we insert zeros on the other end,
Okay,
so that after we execute
Hmm.
every
I
instruction in
got
the
it.
batch,
We don't need a mechanism. You're right. I got it. Let me explain to Mageta because I think he didn't follow. Mageta, let me explain.
Hmm.
So put 6 numbers there, Mageta, randomly, just for me in order to explain.
So to start the stack with
Yeah, no,
6 numbers.
this is just for drawing mechanism and just for you to
Okay,
me to
okay, okay.
explain to
Let
you.
me do this then.
So you put 6 single numbers there, and let's imagine that these numbers are every single number is an opcode. Okay.
Oh,
Okay.
there.
So in the beginning of all, PC is going to be 0. Okay. And as Marinho
Yeah.
said, every single time that PC is 0, uh, uh,
ISR
well,
actually.
the ISR is 0, sorry. Every single time ISR is 0, that means that we're going to do the fetch. And then you scroll down, uh, scroll down into the instructions that we did today. One of them will be the fetch. We're gonna have to change in the enum here. So every single time the ISR is 0, that means that we're gonna do an OPPC fetch. So we need to go to the enum and change the order there, but we can do that later. What does this instruction does? This instruction moves the PC forward 1 unit and puts 6 non-zero values of opcodes into the ISR. Okay, so what we just did, this is an automatic mechanism to already
So,
populate the ISR.
by the way, this is not pushing 6. It's just pushing 1 right
No,
now.
it's pushing 1 because this is pushing a word, and a word is 32
Oh, I
bits,
see. I see.
and each instruction is 5 bits. Okay.
Okay.
Okay, so remember this. Whenever we reach ISR 0, that means
hmm
that we're going to refulfill that in the next cycle. Okay?
So the rule would be we instead do this on the SR, right?
Yes,
So we find it, and then we recover the value.
yes. And that will be opcode in this case, yes. But the else is going to be interesting. The else is going to be very interesting. Because the else means that if the ISR exists but it is not 0,
Oh,
uh,
we still gotta see this case here, right? Because it's an opcode, but
oh,
it
you're
can
right
still
actually.
be
You're right
zero
actually.
push there, right?
Yeah, if it's 0 push there, we don't need to do anything because as I just explained,
Oh, right. It was gonna go to the
and
okay.
it's gonna
Got it.
refetch, right? Now
Let's
let's
organize this already, by the way.
so
So
just change the blocks. Just change the
so
blocks for and that's gonna fix it.
this the order should be this
The
first.
only one that matters apparently is this one, according to Marinho.
Yes, it is.
The only one that the order matters is the OPPC fetch needs to be the first.
Makes sense.
Okay, so
It has to be
remember, every
zero.
single
Yeah.
time you reach the 0, this is an automatic refilling. Now let's go to the case that we were drawing with the 6 numbers up there. Go up a little bit. So what we're gonna do? We're gonna do a shift. So let's imagine that the first instruction is the leftmost one, okay? So it's the number 1 in that case, right?
hmm
So if we're gonna shift to the left, we're gonna grab the 1 saved somewhere, but here's gonna be 0. Do you agree?
Yeah,
Instead of the 1, it's gonna be
that's
0.
right.
Every single time we shift to grab an instruction, we are basically removing one opcode and fulfilling that space with 0, right?
hmm
When we
That's
are
not.
done, when we are done, everything will be 0, which
And then
means
you refuse.
exactly, and then it goes on and so on and so forth.
Makes
Yeah, that's
sense.
not quite right. I'm going to write it on the chat because I can't share screen, but I'm going to use the 1, 2, 3, 4, 5, 6 example that Mageta wrote. So initially, we have those 6 instructions, right? Those six
Yeah,
opcodes.
yeah.
And then what's going to happen is we're going to grab the first one and execute it. And as we are doing that, we shift the next one over,
Oh,
which
Commander
means
Snipe.
that after we execute the one, the ISR will look like this: 2, 3, 4, 5, 6, and then a 0 because we shifted over the 0, right?
Uh-huh.
Mm-hmm.
And then it's gonna
On the
refill
next,
the space, and then it's gonna
yeah.
be on the
So
sixth.
on the next,
No, got it.
yeah. So on the following cycles, we will execute the 2, shift over. That there will be 2 zeros at the end, and
hmm
then we keep doing that, right? Um, and then eventually, the next instruction will be a 0
hmm
because we shifted over all of them.
Yeah, and this is the beauty of it because that means that it's already automatic refetching.
Yeah,
hmm
because the 0 opcode is the one that fetches the next group of instructions, you see?
Yeah,
Yeah,
yeah.
makes sense.
So that's the clever part. That's why we don't need a mechanism to see where we are. We are because it's naturally going to be re-fulfilled with the next set of opcodes. The only thing that you need to discover now is because this is now we're talking about bit manipulation now. We're talking about masks. Talking about shifts. I have no idea how objects in Objective C handles this type of crap.
Like C. If
Let
you can
me.
guess to a primitive and use like a mask, for example, you can just do end
Okay,
the same way.
so we're gonna basically go down to the pedestrian sea world, do the
Well,
mask,
yes,
and then go up.
pedestrian. A little offensive. Man.
I mean,
Okay,
I
so
can't drive, so he's not wrong.
okay, so let's do it outside as well. Just notice this.
Yeah, let's do outside. I think it's
So okay,
actually we
let's
should make a function for this type of crap.
yeah, let's just try to do here and then we do the sketch somewhere. So find an enumerator. So we try to fetch SOR, ISR, and
Yeah.
SOR is system of records in my company, and then I keep anyway, which is like a distributed
Yeah.
thingy. Anyway, uh, then we try to grab something from the ISR.
Yeah.
One, right?
If it's 0, we do nothing.
So let's do this here. So one thing I'm concerned though, we need to push the correct things because by the way, these opcodes here, they are mapping to. So here's what I'm concerned. You said about the word, right? Here.
Yeah.
So each one of them would be. So you're considering beats, right?
Yeah.
Yeah.
But
Uh,
is our representation right? I don't think it is, man.
I think it is because why don't you think it is? Tell me why don't you don't think so?
First of all, this should be a U integer to be accurate.
Sure.
that's fair.
So
But
what's the
here's
problem?
the so we're trying to push things to the ISR, and it's one opcode that is represented as numbers here. So
Yeah.
0, 1,
1.
2,
Yeah,
3.
exactly. Exactly.
We gotta check if this is actual 0, by the way. I'm not sure.
Sure.
Assuming it is.
There might be a way to force that, but I have no
In
idea.
C, you just put an equal to force it.
Can we do equal? Oh, we can.
No, you don't need to do the other ones. It does
Yeah, that would
automatically.
be cringe. Let's.
Yeah, the other ones don't actually matter.
Yeah, apparently the other ones they don't matter. We are just having them as this to be organized. But the only one that matters is the fetch.
Okay, so let's assume it's 0 here.
Sure.
Sorry. We got this, which is 0,
Yeah,
right?
the
But if
opcode
we
is
got
0.
like
That's what it means.
10, if you got 10, whatever, or some number that is bigger than the
What?
okay, the point is you cannot have something that the amount of instructions that is bigger than the word count, right? You
No,
have.
you don't. You in our case, you don't even gonna have something greater than 5 bits. So you're talking about maximum of 32 instructions,
Yes.
which Marinho said it's apparently 20 instead of 32.
I think it's 28. I don't recall the number off the top of my head because there are a few opcodes that the paper doesn't really use. So yeah,
Yeah, so I think we are completely fine with 5 bits.
we could go higher or lower, but that's up to you guys. I'm
No,
just
I really don't think we
here.
need to go higher, but I want to see if because Magenta is processing. I want to see the result of that.
Yeah. Okay. I think let's go with this. I think I am getting an idea. So, okay, so this we don't need to do anything with it, right? We just grab the thing if it's already there.
No,
Do
no,
we?
we do need to do something about it because if it's not 0, that means that we need to do some shifting.
Oh, right. We need to shift the next one.
If
Okay,
it's
got it.
0, we do nothing.
So we need to shift the value inside ISR, right? Right now.
Uh, no, not
Uh,
ISR. You need to shift opcode because opcode right now is a 32-bit thing, right? It's a
It is.
32-bit thing.
no, but wait,
Or
we
how
need to
about
save it somewhere. We need to save the current thing somewhere, right? Otherwise, we're losing always one instruction.
No, no, we are not losing because ISR is not being popped. We are just doing a lookup, so it's always there.
Oh, right. Makes sense. So, okay, I think we can just do
Oh, but
then.
I think you're right. We need to mutate ISR also, right, Marin?
Yeah, that's what I was
we
thinking. How are
do?
you going
We
to
do.
save the.
We do. Well, but it's an ID, so it's a pointer, right? So if we change it, it's gonna change both, no?
Yeah, I think so. I
Okay, so
have
let's
to.
try
Uh,
that.
I
So
don't
so
think
let
that's
me.
quite how numbers work at a very low level in Objective C.
I have no idea. We're gonna have to try. Search, Magneto. What do you
So
want to search?
shift. I don't remember how you shifting C. I remember mask because it's just an
No,
end.
in shift
But
is greater than, and smaller than, smaller than.
with another thing, right?
Yeah, you. But that's the thing. We have two bits that are garbage. We need to take care of those. So what do you
Um,
recommend us to do, Marinho?
Oh, I see.
Uh,
There are the
you
8 bits, right?
Yeah, we have 30
you can just
bits. Go on.
you can just do a NOR to make sure the lower two bits are always zero.
Okay, so do that. So
Ah,
do a
or
normal,
I
do an
mean,
OR first, Magetta. So
no,
OR
no,
is
no,
a
an
single
end
pipe.
actually.
Oh,
You
an
have to
end.
do an
No,
Sorry,
end actually.
an
yeah,
end.
nor will
Yeah.
just ignore.
No, not that end. The other one with only one A.
Yeah, the
Yes.
bitwise
Yeah, the
end.
bitwise one. Assuming it works with objects, which I doubt it. So
Oh,
we
let's
need
We
hope.
the.
can just we can just cast it to an integer because it's actually an integer at this point, right?
Yeah, so we should use the this.
Yeah, but that's an object, right? So we are assuming it's gonna work the operation with that.
Yes,
So
I
what is
understand.
the oh my god, this is so microcontroller classes, man. Again, once again. Let me see which number is the one that we want. We want the ones that just zero the remaining two bits you said, Marin.
Yeah, we have to do something like
I made it already. FC. It's x in x decimal FC.
Yeah, FC,
Yeah. Put in
which
capital,
is
please. That's triggering me.
ah the screen.
And there is a neat way to do that, which is the and the equal instead of doing. It's almost
Oh,
like
like
plus
this.
equal. Yes, like that. Yeah. That's so
That's
microcontroller days, man.
that's not that's not quite right
Oh,
because
I'm missing bits, right? It's 32. So 1, 2, 3, 4, 1, 2, 3, 4. So it's actually FFFC. So it's three Fs
I'm
instead of one.
pretty sure there's a way to do that. That's actually size independent. Let me. I remember. I know that because I did that recently. Actually, let's see. Um,
oh
Now you can
that.
shift. Now you can shift if you want,
Man,
because
let
now
me
we are.
pick the calculator. I'm not sure if this is right. I
What do you
don't
want to
trust
know?
you. So here, it's we. Let's assume we have this, right? So 1, 2, 3, 4, 5, 6, 7,
It's
8.
30. It's
So
32 bits. Remember that.
okay, but we're gonna have 8. Oh no, we're pushing 6. Never mind. So 1, 2, 3, 1, 2, 3, 4, 5, 6. This.
No, no, no. We have 32 bits, Magetta, and we want to have zero the last two ones. So you need to put 30 number ones there.
So okay, got it. So I was thinking of the slots, not of the beats.
Yeah,
Actually,
now
that's
we
the
need to
problem.
think about the slots because well, only on a high level understanding of the crap. Hello, Sophia.
Hi.
hello.
Mm,
You arrived when we are doing the math part.
the cringe calculator. I
We are
think if I
The
doing.
heck?
type just on this calculator, if I type like, yeah, okay, it accepts numbers like normal.
Okay,
Wait,
but Marinho said there is
what
a
the
way
heck?
to do a mask without depending on the size.
Which is
Um, yeah, you actually have to do. Let's see.
We are doing a virtual machine stack based, Sophia. That's what we're doing here.
in Objective C for some reason.
What the hell? Objective C is so ugly.
Well,
Magetta enjoys a lot.
yeah, it's pretty cute. Pretty cute.
What the hell?
It's so
I find
different.
it pretty cute.
The
Yeah,
only thing
it's
the thing that
it's a
I hate the most is the fact that he uses void stars everywhere. That's the worst part.
Yeah.
it's a poor man's small talk. This statement.
Yeah. And now what we are doing, well, we can check the. I think Marinho sent the paper
Right.
on the Gmail chat there.
So there is a way to do this that actually doesn't depend on knowing ahead of time the width of the number, which is kind of like this. Um,
I'm
Actually, I
very
wrote this,
curious, man.
and actually, I'm testing this out right now in Racket, so you know it works because Rebel
Oh,
So how do you do a mask that doesn't depend on the size? Teach me.
like this.
Bitwise and
What bitwise and does in Racket?
so what is this B dash? I suppose it's a
That's
byte,
just
I know, but
that's just how you write numbers in base 2 in Racket.
oh,
So
I see.
so basically, I'm saying I'm taking the number 8, right, and
Mm-hmm.
then negating it.
Mm-hmm.
That's equivalent to
That's a
doing a
bit
mask
different.
that has 0 on the bottom two digits.
Wait,
And then
is
the
this grabbing every single binary number that ends with two zeros?
yeah, like
What?
let me just copy the REPL interaction here so you guys can see.
That's crazy. So they do have a mechanism to be size independent. That's crazy, man.
Let's see. So
So you're doing a bitwise AND with the thing that ends with two zeros with the number
mhm.
there. Wait, I'm confused now, actually.
Oh, I see. So it's peaking on the first
Oh,
one.
I see. Now I see.
Oh, and for the record, I'm just going to add another line to that thing just so we're
Oh,
all on the same page. Oh, Sophia's gone.
That's no problem. Wait. Uh, okay,
So
so
you see,
Racket does have it.
it does.
It does have a way to make a mask that is well, but this is not Racket. This is C. So I think for now it's okay.
But it actually works the same way because
yeah,
this
that's what I was
actually is
thinking.
based on choose complement, which is how C represents, well, it's how modern machines represent signed integers.
How is the C equivalent of this then, Magita?
So if we do, let's drop this. So I think, okay, it's gotta be on the first anyway, right? But we still gotta do this. You're saying? Oh, this is hexadecimal, right?
Yeah, that's hexadecimal, man.
Size
It's not
100.
binary.
How does I don't I actually have no idea how you do that. What Marinho said in C. I have
I
absolutely no
wanna
idea.
see. How do I?
That's just -8. It's literally just the number -8. The signed integer -8.
-8? Oh,
Yes.
minus if you pause it here.
No, you don't need to put the hexadecimal, man. Just put -8 there, Magita. Yeah, there. That is it. If what
Oh,
Marinho is saying holds,
man, let's leave a comment here, please.
that's
So, because gonna look at this next week, and I'm not gonna know anything. So,
this is a mask to remove the final two bits out of any number, I guess. Don't put final, put rightmost, because I think final is gonna be depending
yeah.
on the semantics.
Well, rightmost also depends if it's little Indian or big Indian.
I think
Uh,
final with little endian makes more trouble than rightmost. I think rightmost is more
yeah, but
independent.
actually, I don't think this will quite work
Indian.
with a 64-bit machine because the number of bits that are left over at the end is different.
The leftover.
Yeah, like in a 32-bit machine, which is what the paper assumes, there
Mm-hmm.
are 2 bits that are left over, right? Because you have 5-bit instructions
Yeah,
times 6, that's 30 bits.
yeah,
There are 2 bits left over, and you have a word.
yeah.
But if we are, but if our computers that are running this code are 64 bits,
No, but I think
and
our
we
integers, I think the integers that we are using are 32, man.
are they?
I really think so. Can you
The
check?
integers we are using.
Yeah,
This, you
what
mean
is an
these integers?
NSU
Uh,
integer?
Actually, these are 64
Oh,
because they're
then we
long
are fucked.
integers. Yeah, assigned
Yeah,
long integers.
because for a long integer, for a 64-bit integer, we have if we still have 5 bits in opcodes, we can have as many as 60 bits being used for opcodes, and then we have 4 left over. So the mask is different because there
Oh,
are
okay, we're
4
gonna have to
extra
make a
bits we
decision
have
here
to.
then. Do we want to scale down the NSU integer to something that is 32?
I think it's better.
I think it's better because to better follow the paper because we are getting to the point of saying of bits and stuff like that.
So let's see. So it's just a normal int32, right?
Well, check the
Yeah,
annotation in the
basically.
hover. Oh, you're using C types. Okay, then I think
Yeah.
it is.
So
Yeah,
then we need to change everything here.
Yeah, we're gonna have to change everything.
Is there any problem me using the unsigned? I don't think there is, right?
for the opcodes, no, I don't think so.
But there are problems
Uh,
with data stacks, and I believe, right? Data stacks you need to use
uh,
int32, not
no,
uint.
that's no, because when we implement the arithmetic instructions, we can just cast them to a typed, to a signed
Oh, that's right.
type.
We can make it local. We can make it local.
Oh man, no, you're kidding me. Dude, these retarded objects from Objective-C, these IDs, they are of a higher size.
That's
They
the
are
Yeah,
actually,
problem.
I
they are
suspect they're
pointer sized.
64.
They are pointer
Okay.
sized.
Yes, they're 64. Oh man.
Okay, so I think because of
This is
because
really
of the
crazy.
technology limitations, we're gonna have to double up the amount of instructions, right? Am I right, Manin?
Um,
Eh, I don't. Let me think for a moment.
Well, we can discard 32 of them, the first 32 if we want. We can shift 32 before doing the
Ah,
mask.
but then we are wasting half of our memory. Like literally half of our memory
I
will be
understand
wasted.
that. That's why I'm asking. What should we do?
I mean, it would be nice if we just could use 32-bit integers everywhere, but
But the object system
that
doesn't
doesn't.
allow us.
Yeah.
uh,
Actually,
let's
it's
see
even
if
worse
we can do
because
it.
it's machine dependent. However, a pointer is 32 bits or 64, right?
Well, yeah, but that part is the one that I'm less concerned about. Anyway, we're gonna make a decision. Are we gonna waste 32 bits or are we gonna double up the amount of instructions? I think it's okay to double up the amount of instructions.
Yeah, but then we have to make sure that the registers.
Man, let's think here. Like, if we are like we're you are first considering that it is an option to downscale, right?
But it
But
is an option.
let's think if it actually is. I'm not sure
No, 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 no,
because
no.
it's
Wait,
an
wait. Let me
integer.
make myself clear. I'm not saying it's an option in the code. The code's gonna be 64, but it's an option to do a shift of 32 bits and ignore the first 32 bits of the 64 thing.
But then we have
Oh,
to
okay, we
mask
can
off
do that.
32 bits everywhere, right?
Yeah, yeah.
Yeah, I
We
think
are gonna have to shift everywhere.
everything's gonna have to be shifted 32 every single time. That's why I
We could.
think
Oh
we could
man.
double up. We could just have 12 instructions per ISR instead of 6. And then we just shift. We need
We
to
can
get
just
rid of
fill.
the remaining 4 bits.
Can't we just fill with like blank instructions and do nothing? But this is man. I'm pretty sure this is how Unix started. I'm pretty sure. What if what if we do this and then it's like a huge gambiarra that this thing.
Yeah, but why?
Ah,
What is the benefit of having a bunch of? There is a name for that, man. In Risk 5, the one that does nothing. I don't remember.
mops?
Yes, NOPS. Yes.
There is an op in the instruction set actually, but it's
Yeah,
not
there is
zero
already here. I think.
because zero is the instruction set. So yeah, we have
Wait.
problems there.
Can somebody tell me what is the problem of doubling up aside from paying attention to every single time 32 bits matter? Can somebody explain to me?
Oh, I thought it was just that.
Um,
Which is already a pain in the ass, but
No, no, no. If we
we
double up, we don't have to do anything at all with the rest of the code.
like if we double up, we have to make
all right,
sure
we're
that
already
the
using 64.
registers don't fall outside of the 32-bit range, which will require some extra checks.
Wait,
And then
why does the registers need to be 32 instead of 64?
because the machine is 32 bits internally, right? That we're implementing.
No. But I'm suggesting to double everything up. That's my suggestion. To just
But
do times two.
no, be precise. When you say double up, you mean use long integers
Yeah,
everywhere,
yeah,
and then you
everywhere. So
do a
every single
shift
register.
everywhere.
Yeah, every single
Yeah, and
register that would be 32 would be 64, including the ISR.
We can do that. The problem then is that the code won't compile for a 32-bit system if we
Yeah,
decide to do
I'm
that for
yeah.
some reason.
We
and
don't
you
need
are
it to run in
totally
Mageta's
okay.
consoles, man. We don't need that.
Oh, what do you mean, man? I want it to run on my Sega Saturn. That would be amazing.
Yeah, we don't need it to run on that. That's not a priority.
The Sega Saturn is actually no, it is 32. Yeah, it's 32
Yeah,
bits.
yeah. I understand that. Uh, well, I am more concerned with the thing being a less pain in the ass. That means using 64 bits. If you guys really want to make it compatible with 32 bits machines, uh,
Actually, I
then
don't care, to be honest.
I
I
also
mean, it
don't
would be
care.
cool. It would be cool if it did, because think about this. Hmm.
Man, we're gonna have to compile Sega Saturn's assembly to our
No,
stuff
dude,
to compare.
I have a Power PC Mac Mini, which is 32 bits.
Yeah, we're gonna have to to make it run there.
How cool would it be? And it's Objective C, right? Which I can easily just import there.
Yeah, that's a thing. That's a thing,
That
right?
would be cool. Imagine our VM running on Power PC, man. That would be so cool.
Well, I'm waiting for the expert. Marin, aside from incompatibility with 32-bit machines, what else do we gonna have to trade?
Uh, Nothing actually.
Okay, so it's just a matter of deciding do we care about 32-bit machines. Mageta.
Oh, I do.
Okay, so if you do, we're not gonna complain anytime about the asshole, the
Oh, I
pain in the
didn't
ass
say
it's
that.
gonna be.
I did not say that. Okay, just
Because
tell
like,
me what to do and we can try to fix and make it better. So
O-
what do I do
okay,
here now?
okay,
okay, so instead of -8, we actually have to do, let me check here.
So I'll put 64 here. I'll keep it as it was.
yeah, but we're gonna
It
have
will
to
have to be
convert
minus
that to 32 crap.
Yeah.
No,
So here,
are we going to convert to 32 bits or are we going to with 64?
No, we're gonna go with 32 bits because Mageta wants to run in PowerPC, man.
why not,
Oh,
man?
because okay. Uh, so for 32 bits, we keep the -8 there. That's right. We have to we have to do something about the data stacks because
No, everything is
currently,
wrong now. Everything is wrong.
yeah,
We're
they
gonna have to
are.
go one by one into the operations with stacks and registers and crap, and we're gonna
Oh,
have to
that's
do
fine.
some shifts there.
Okay, let's do a function to shift stuff, actually. I think it will help. So let's go to the utilities, the good old utilities. And what we pick and what we return.
Let me just predict the future. We're gonna make this, and it's gonna be okay. We're gonna make this happen with all the 32 crap, and then I know when Magetta powers up his power PC, it's not gonna work, and then we're gonna not gonna know why.
And
Oh,
then I'm gonna get sad because, well,
It's gonna be so fucking sad, man. Okay, but I have a question to you, Marin.
yes,
How are we gonna do that? So we have 64 numbers. Uh, well, we have numbers distributed in 64 bits. I'm assuming
yeah,
that we're gonna zero the leftmost part of it. Is that what we're gonna do?
yeah. Like for the code, if we run it on our 64-bit machines, we just basically ignore the higher 32 bits
Okay, so
because
Magetta, just make a don't put magic. Put 64 to 32, the name of the function, basically.
integer. Just put value.
Yeah, but call this 64 to 32.
Here, one typed like 64
Well,
to
I didn't mean to do that, but
64. Can I put an arrow here? 32, probably not, right?
No,
Yeah.
because
Put
that's
the
the
true
arrow is
TO.
key syntax for.
Can do this.
Put, yeah,
That's
but
cursed.
can't you put the 2 64? No, no, not in the beginning.
Yes, but I can't put the number. I can't start with the number. I can do this.
Oh, you can't start with the number. Okay, so
No, I
put in
can
the big.
type.
No, no, no. But you're not gonna type, man.
Yes. I mean,
Uh,
I need to do this to work.
yeah, that. Oh my fuck. Okay.
Put a
Uh,
from there, from 64 to 32.
yeah, put a from.
Okay.
Yeah.
We
Also, is
just want
what
to
is the
leave
name
it.
scheme? Luna, look at line 11, man.
What's the issue?
What's the issue? Don't you see that you are using snake case in one and camel case in the other one?
Ah, whatever.
Whatever.
It's fine.
Okay,
This is so
now
common. This is everything.
now you're gonna do a mask. You're gonna put the value and then end, single end, right? Because no, it can
So
be
let me
returned. You
just.
don't need to make an intermediary value.
So okay. You're saying I should just type here. Okay.
Yeah, just put return and then value, bit end,
Turning.
and then you can do the trick that Marinho, Marinho, what's the number for 32 to 64 using, or we're gonna use the mask that I know, or you're gonna use your trick.
I mean, since we know the input size and the output size, I think it's fine to just do something like this, like return
No, but
value
that's
and
gonna no, but that's not right, right? That's gonna allow all the bits. We want to remove the first four, so it's 0000 F F F F F, right?
no, we're taking 64 bits and we're returning 32, right?
Yeah.
If you count the Fs, you will see that that is actually one, two, three. It's actually 32 bits on the left of the end that I wrote.
Oh, this is not 8 Fs. 4. No, this is 8 Fs. This is 64 bits, man. What?
An F is just 4 bits, man.
An F is just 4 bits. You have no, you do have 8. I am blind. Sorry. Yeah, that's why you need to end my get there.
Okay, so
Oh, I wrote the hash X because that's how you write it in brackets, but it's actually 0x, right? You see?
Yeah. You
zero
put
eight
yeah, you
one
put
two
that.
three four five six seven eight.
Yeah. Okay, so this is how you're gonna have to do that everywhere, man.
Well,
Ah.
it
Okay.
is a decision.
No, it is a decision, but if I'm okay with it. I'm okay. I'm okay.
As long as
I
it
know I'm gonna
runs,
regret
yes.
it, but I'm gonna do it for you, Mageta. I care.
No,
I care
actually,
about you, man.
I
you only have to
coded the
do that
entire.
and when you are reading
The
from
data
a
stack, the
register.
return stack.
No. You only have to do that when you read from a register or you write to a register. Um, for the stacks, is there
I
is
think we
there a
need to do it.
problem with using a C array of 32-bit integers instead of an object for the stacks?
That would be the same argument of not using objects at all.
No, because like I mean,
But Mageta doesn't want to make the structs from scratch.
Yeah, that's what I was thinking. I think we could save ourselves if we did the structure, right? Because then we can enforce the typing.
Yeah, but you didn't
yeah,
want that.
because
Oh man, that's
no,
too
I mean
much to do.
you only have to implement the stacks like this. Everything else we can do in Objective C. That's not a problem because it's just implementation details.
So the only thing you're saying is the map to do in Objective C
Yeah, basically.
ourselves, right?
No, 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 no. The Objective C, we're not gonna do ourselves, right? We're gonna just reuse what is already written.
No, I'm saying the map we should do ourselves because that's messing with the
No, no, no.
No,
He's
registers.
talking
no,
about the stack, man. The stack
the
that we are
stack.
using Objective C, we would make it ourselves in C.
Just to make sure that the values in the stack are all 32 bits. Otherwise, we're going to waste a bunch of space on the 64-bit machines.
No, but we
And
already
also,
bought
we
the waste. We already bought the waste, Marin. Oh, there
no,
are
but
three
that's the
options, Magita. First option, we
Right.
just do everything 64. Second option, we do everything 32, And if we want to do everything in Objective-C, everything needs to use that transformation that we just made, including the stacks and the registers. And there's a
And the
third
RAM.
option, and the RAM. And there is a third option, which is a mix of both, of like the maps containing the registers. We use Objective-C, but when we are writing to a register,
Okay,
you need
okay.
to do the mask.
So what makes it less? What do you think is less painful that maintains some compatibility with 32?
Uh, Definitely not the first option. It needs to be on
Yeah.
one of the two later options. And between using everything on Objective-C and doing casting all the time and implementing the stack ourselves in pure C, the the fastest one is doing the casting all the time, for sure.
The fastest one in development time, right?
Yeah, in development time. That may bite us later,
Yes, I agree.
but the
So here's
fastest one.
so here's one thing. Do you want to just do the easy route to implement this now,
I'm okay with that. I'm okay with
and
that.
then we open another PR, and then
We're
we
going to
change
implement the
the
stack
approach.
ourselves in C.
Yeah, because I just don't want to implement a structure right now,
That's okay.
especially in C. That's
I kind of want
gonna
that.
be
It's kind of nostalgic, but I
I
can do
yeah.
that
mean,
later.
it's basically just an array with
Yeah,
a
because
few
we're
helper
gonna have to
functions.
unlock, right? We're gonna have to fix the lengths, watch for the lengths. I don't want to do that.
Yeah, we're
It's
gonna have
just
to do more memory management for sure because right Objective C is completely hiding is doing the garbage collection, right?
It's
Uh,
actually reference counting, I think. But yeah.
okay, so it's reference counting, but we don't have to deal with that. And at the time that we make our own, we may have, and if we want to be more pedantic, we're gonna use malloc and all that stuff and
okay. So
freeze and
let's just cast everything for now.
okay.
It's gonna be painful, but we have very little, right, to worry about right
Yeah,
now.
right now it's very little. Right now.
Yeah, so let's just do it now, and then we change for the data structure. So okay, let's go back here now.
Okay,
Let's
so
go one by one.
you
So
grab the ISR. So now we're gonna
yeah,
have 6 instructions, 5 bits
so
each.
this is an ID. Just have bear this in mind.
Yeah, so but this is a 64 thing. So the first thing that you need to do
So
after
let me
grabbing the
put
ISR,
actually int 64t. Let me already put it like that.
after the immediately after grabbing the opcode from the ISR, you need to do the transformation to 32 bits immediately.
So actually, let's put 32, and then we call from 64 to 32.
Yeah. Then you do the trick with the -8 to remove the garbage.
Wait. Int 64. Okay, and then I do
You do the -8 to remove the garbage.
this.
Yeah, the -8.
Yeah.
Yeah,
Wait.
because it's 32
Uh,
bits, that's right.
yeah.
And then
Yeah. Then you need to do a shift now. You need to do a shift. So
It's
actually,
okay.
well,
Only
actually,
what?
before you do the shift, because the shift is going to mutate the opcode. Write into the register ISR what you just have as an opcode. Or you do
So
that after the shift. Marine, you do after or
uh,
before? You do
I
after,
mean,
right?
what you have to do after, because what you're gonna do is you're going to read the first 5 bits, which is the first instruction, right? The first
Yeah,
opcode.
yeah.
Then you have to do the shift and put that back into the ISR so we can continue in the
Okay, so you
next
actually do the
cycle.
shift first, then you write it back, Mageta. Sorry, sorry.
so set object.
Yeah, but the bits that we are shifting out of the number, they have to be saved somewhere so we can do the dispatch, the case we're doing below.
Wait, we need the
Not
bits
actually
that
a
are
case, but
garbage?
no, I mean, we're reading an instruction. We plan to execute that instruction, right?
Yeah.
So we need to remember the instruction after we fix the ISR. So, you know,
No, 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 no. Ah, no, you're not saying about the 2 bits that we just removed. No, you're not talking about those.
no, I'm not talking about
Okay,
those.
sorry then.
Okay.
Okay, so Mageta, here's the thing. The next line, actually change the name of opcode to opcodes to be a little bit more semantically
Yeah.
precise.
Of course.
Okay, so now we have
Okay.
opcodes. We have 6 in there. So now you're gonna make an opcode out of scratch, and
So let's do this like this. I think it's better. So opcode and opcodes,
yeah,
And then here, this
This
is
is
still
opcode.
64. Yeah, this is
Yeah,
opcode. Does this stay 64?
yeah.
Uh,
Actually, the opcodes will be just
no, you need
there's
to be
no
32, I
5-bit
think, right?
integers. Like C doesn't have 5-bit integers, right?
Yeah, we will have to use an 8-bit, which is the smallest available.
And this thing needs to be 64 because when we write, it needs to be
Okay, that's not
uh
a problem. We're gonna just have weighted space, but like I told Marin, we already bought into that. That's okay. Okay, after line 43, we're gonna make upcode equals to,
so I need to compare after this
yeah, after that
opcode.
equals to,
Wait, opcodes or opcode?
no, opcode
Singular.
in singular,
Okay,
yeah.
but it's not anything at this point.
Yeah, that's what we're gonna do now. We're gonna do inequality now.
Okay, is equals
Why are
to.
you checking
Yeah.
is equal though?
He meant
And
an
I'm saying,
assignment, not an
Yeah,
equality.
oh, it's an
an
assignment.
assignment.
I heard you saying is equals to,
No, no,
but
sorry.
anyway.
It's is equal. My bad. My bad. I said it wrong.
Oh, okay, equal like this. Okay,
Yeah.
assign. Okay, go
Okay.
ahead.
Now we need to grab the first 5 bits out of
The
the
highest
the
5 bits.
the
Yeah, we
highest
have to
five
do
from the opcodes, right? Do you have the same trick, Marinho, to do that, or are you gonna do my way?
that's just shifting 27 to the right, right?
To the
It
right or to the left?
depends on where the parameter is, I think. If it's like this, I think it's the right.
That's gonna be 27.
No, I mean, like there are 32 bits in the opcodes
Yes.
plural, right?
Yes. Yes.
We're interested in the first
5.
5, like left to
Yes.
right, which means we have to
Oh,
do.
it's 20. It's yes, it is. It is 27 to the right, but I don't think it's hexadecimal. I think it's
It's
what
It's
just
not.
Magetta, what
integer.
Marinho said in the chat, Magetta.
I see.
Yeah, and it's back, and it's the other way around. The opcodes are on the
Okay.
left of the shift.
Yes. Yes. Yes.
This.
Okay.
Okay.
Now, next line, you're gonna do the same thing. I think, right?
Yeah, the next line will be something like opcodes plural,
Equals
because, and then we're going to shift 5 bits
27. Yeah. Now
to
we're gonna
the left.
mutate the first one, Magetta. We just saved. No, it's
Right.
5 to the
Yeah,
left.
it's
5 to the left.
yeah, it's
Not
5
20.
to
Five.
the
I
left.
said
Okay.
it wrong. 5 to the left.
To the wait, to the left.
Yes. So 5,
25. Okay.
and then you write that into the ISR register back.
And then I write
Which he's
this
already
back.
doing. Yeah, he's already
Set
doing.
object opcodes.
Yeah. That's it. We need to do
And
some
then
typing maneuvers there, but probably
and
that's it.
then I need to convert it back. And then this is gonna be back at 64.
Okay, so let me explain to you what we did. First, we grab the line from starting from line 41. Okay, so first we grab the 6 opcodes out of ISR. Then line 43, we remove the 2 garbages on the right.
Right?
Then we pick. We want the 5 to the left, the leftmost 5 bits out of a 32 thing, right? So we did
Right.
a,
And then
a
you have
shift of
five.
27.
Okay, 25, 27 last 32. You have five, and then you just
Yes.
shift to the left five. Okay.
Yeah, you are doing the 45 to remove the ones that we just saved.
Mm-hmm.
Okay? And then you put that back into ISR. Now, what happens in the else of this thing, right? Because we have an else. So if you have an else, you need to throw an exception. No, oh no, we're not going to throw an exception, right? We're going to read from memory itself. Right, Marin?
If we have an else, we can just say the opcode is 0, I guess.
Okay, so opcode equals 0.
So
Actually, we
opcode.
should use the enum at some
Oh,
point.
right.
Oh, you should use the enum. That's correct. Op
OP
PC fetch.
PC fetch.
That's it.
Second type.
Uh,
That's it. Okay. Now, now, now it comes the now it comes the thing, because now we need to.
actually, I think yeah, opcode has to be 0, which is the PC fetch, but I'm not sure, like, in terms of types, how to make that not break the compiler.
I don't know if what you mean, Marinho.
I mean, how to do opcode 0 and then cast that into the enum without breaking the type checking.
I think that's not a thing in C. You just you just do the casting and the type checker will not complain. In C,
Does
in
that work?
Objective C, maybe they have more safety on this regard.
I don't think it does actually, because technically Objective-C is a superset of C.
But C allows you to do that. I remember converting numbers to enums.
It should be okay then, I guess.
Because enums
Just do the.
are just named integers actually in C.
Yeah, I know that. But I'm not very familiar with C's type system other than it's very
Wait,
loose.
Magenta, can't we compare? Can't we cast a 30? Oh, we have a 32 crap.
Yeah, we need to compare here, but this is a pointer for 64, and so we can compare this, right? So this is
Can't
32
we
now.
just can't we just cast the
To
opcode
64?
no no
Oh,
to an
probably,
NS integer, I guess.
probably we can
NSU.
call the same thing here. Like,
If it works, bad receiver.
at receiver type.
Oh, that's because opcode
Oh,
is a uint32. Um, we actually have to. Uh,
don't think that is the case.
But I want to know why can't you cast an opcode to whatever the OP halt is?
Oh, I can
uh,
cast this to 64.
Yeah,
Yes.
that's what I thought. How much time we are here? 2 hours. Okay.
So can I just cast this?
oh, I think I know a way to do this. So like on the line 41, where we're defining the opcode, right, to be the
Mm-hmm.
shift of the opcodes, we have to do something like opcode equals, and then we have.
Oh, just think, don't we want just to ignore some values? Why don't we cast? Okay, we do this casting and it's gonna eliminate,
The
and then
first
we cast
32, I
again to
guess.
64.
Like we can do something like this, and then on the opcodes declaration, we change the type to be an NSU
Yeah,
integer, I
okay.
think.
Yeah, I agree. That's what I
That
said.
Okay.
should be the least, the smallest change that should work, I think.
Yeah,
I don't know if
that's
I
it.
followed. So you were suggesting to change what to what?
So if you do you agree if you change the opcode, which is the thing we compare everywhere,
Change to what?
needs to be a 64, right?
Sure.
The problem is when we compare here, it's gonna compare with a 64 because this
Yeah.
thing goes inside the stack,
Sure.
right inside the pointer. So what Marinho is saying is that we use the same thing, but then we assign this thing here to cast to a 64. So we do whatever we need to
Ah,
do,
okay. I
the
see. I see.
shifting, but we keep the type. You see?
Okay, I see. Another thing,
That,
we can change the declaration from line 38 to line 41 as well. There's no need to do separately.
just see here.
Would this gonna work? Oh,
I
we need to
have
change the
no
type
idea.
of opcode to
Yes,
NSU
sir.
integer.
I'll actually put ID back.
That also
ID back.
works.
Uh, what about this? I think I need to do the
There's another
St.
thing though.
Paul
Can
instance.
you remove line 38 and put the declaration on line 41?
38.
Yeah, just put the U integer
Yeah.
32 down there.
Oh, but if I, oh yeah, it's not being used
This is
anywhere else. No?
temporary, just to read the
Mhm.
ISR.
Yeah.
Oh man,
Okay,
you
so
prefer declaring and instantiating separately like Fortran? Why?
wait, me?
Yeah.
I didn't say anything.
No, but you did it.
He just
No, I
he
did it
just
that way
moved the
because I
code
thought we were gonna use
a
it
little
first
bit.
because we didn't have this, right? It was just top codes.
No, I would make opcodes equal directly instead of having the equal in a separate line. That's what I mean. Do you understand that you can combine lines 40 and 41? That's my question.
40 and 41. Oh, right here.
Yeah,
Ah, whatever.
this is so Fortran, man.
Yeah, I wasn't looking. Yeah, man, who cares? Ah, okay.
Will this work? That's the
So
question.
so let me eliminate this because we don't need a function anymore. I was thinking of despair already.
Okay, hi
Okay.
Manhattan, by the way.
Hello,
Okay,
Nathan.
this I think this yeah. We
Okay,
don't need to change anything else, I
now
think.
we can go make the parser separating by white spaces.
Well, let's see if it runs, right? I'm not sure about that. And boom, it exploded on my face.
That's
Uh,
great.
Uh, that makes total sense actually because
attempt to read the
we don't
value.
have instructions to fetch, man.
Yes, sir.
That
I
means
mean, we do have halt though.
no, but that doesn't matter because we're
That is
not
on
using the data
the
stack anymore.
yes, that is on the data stack. So how do we? Let's just do a minimal example here.
Okay, so to do that,
Uh,
you're gonna do the
we gotta
following. You're
paste
gonna
through
write
here
to the p
registers.
to the
The memory RAM.
memory. You're gonna actually not no registers memory RAM. You're gonna have to write whatever is
Is
the
this a
code.
stack? No, this is not right. This is a what is this?
It's a
this is a
mutable array.
mutable array.
So we don't have the. We need to add the object, right?
No, we
And
do already have
object.
the object.
No, I'm saying we need to add the stuff inside.
Yeah, we
Like
need to add
oh,
stuff
it's here.
inside.
I
You
see. I
need to
see.
add what the heck we're gonna oh man, we need to think about the bits though. We have
We
six
need a
instructions.
no. We need a we need a helper function to like pack the instructions into words.
Hmm.
So like um so like a function that takes 6 instructions
And
and
returns
makes
a
a word
32
out of
thing, right?
them. Yeah.
Okay, we need a function. Let's go to utilities, Magit. We need a
Oh,
function
okay.
to
So
make
tell me
this
the header.
idiomatic, man. Okay, so the header will be returning ns u integer, and
Actually, yeah.
it should take
It should
six
it,
things.
actually
Backward.
it should return I think it should return a uint32 actually because like we're trying to make sure we don't go over 32 bits, right? Because that
Oh,
would be
makes
larger
sense.
than our word size.
Okay,
And
that's
then it
okay.
has to take and then it has to take six enums of the opcodes
Opcode.
type.
Yeah,
Yeah, it has
opcode
to take
six
six.
times.
How do I call them? Uh,
Inst1, inst2, inst3, and so on.
oh, that'll be no, no. I'm gonna use alphabetic letters. I'm gonna do that.
Fuck.
Uh,
D
C,
T
D.
E
The
I
Russians will never
mean,
understand why we did it that this way, though.
E F
I mean,
one
it
two
would be
three four
nicer
six.
if we could take an array of fixed size, but that's not a thing in Objective C, is it?
Yes,
You
there
can
is
check the
actually.
size actually after.
There is no, no. There is a fixed size. It is called NS array. I think. Just an NS array. It has the.
Wait, do you have
It
dependent typing
has,
on the scrap? What?
oh, it's not dependent type. It's just malloc. That's it.
No, no, no. But what Marinho is saying is that it would be nice if we have something that we know it's six in size.
Well, a malloc would give you that.
No, but not at compile time.
Yeah, yeah, but oh, we're in C, man. What do you want?
Well, we can
Uh,
make an array and check the size afterwards. That's also okay.
it's not showing. Is this wrong? Am I
No,
crazy?
there is an NS array. I remember that from Geek for Geeks, man.
Yeah.
NS
Uh,
array geek for here NS array.
or is this just a superclass without anything?
Wait.
Yeah, because like I'm thinking it would be nicer maybe to have instead of taking 6 arguments, we take an array of enums of opcodes. We
No,
check
it
that
would
the
be nicer,
size.
but we're gonna have to check it. That's why I didn't suggest it.
Let's put that on tech debt, man. I just want to write the parser tonight.
Sure.
Okay.
Okay, so go to
So
utilities.
utilities. Let's copy
Let's make that
this.
function now. Backward. Okay, so now we need to discover how to do the reverse. How you grab an opcode and transform that to a number. Enum to number C.
I need to import.
That's just casting, right?
Yeah, it
That
seems
is
like
just
it.
casting according to Stack Overflow as well. So, but you're gonna have to do some masks.
No, man, you just start with 0. Um, then you
Shift 5,
set, yeah,
put again,
in a
Shift
loop.
5, put again. Yes.
Yeah, start with 0, then you shift and you set it to A, shift 5s. Then you OR it with B, shift
Yeah.
5, and you just do that
Okay,
until
so
you pack.
put uint32. Let's start with 0. So uint32.
Oh,
No, not
let's here.
uint32 word equals to 0.
I hope it's not a reserved. Yes, no.
Okay, now you're gonna do a for loop from 0 to 6.
For int e,
Not inclusive.
not inclusive
Oh,
from 0 to
but
6.
6.
Yeah.
each iteration of the loop will take a different variable,
We're gonna think
like
about
a
that
different
later,
item.
Martin. One segment.
Okay.
So then you're gonna do word or equals.
Oh man, that's pretty
No,
cringe.
not that or. The bit or.
Vitor.
Yeah.
This.
Or equals. Uh, then now we are talking about the order. Are we gonna pack from the left to the right on the arguments or on the opposite?
I mean, if we consider that
I think it should
fourth
be the left
and
to the
second,
right, man.
yeah, they generally execute left to right, so we
Okay.
should pack the A first
So
and
A.
then the B.
Yeah, if it was an array, it would be easier indeed.
Okay, A there.
That's... I'm gonna do what? A bunch of ifs if
No, no, no,
if
no, no,
it's
no. Now
zero.
you're gonna shift 5 on the word. So
Um,
word equals word, shift to the left 5.
so this and then word equals
Equals word, shift to the left 5.
to the left
Yeah.
5.
And then that would be it. But the problem is that we have different names in the line 23.
So let's just do a
Let
opcode T level.
Wait, I don't understand. Okay, so you're gonna make an array then.
Yeah.
Okay, so put
Uh,
opcodes there,
codes
and then you
and
do
out of bounds.
opcode on I, of course. Okay, that would make it work now. But now we need to. Okay, okay. You said you're gonna use old C style. Okay, so that should be okay. So
Yeah,
what's complaining
and
now?
then
Instead of
and then
returning
we have to
0,
do
you return word, by the way.
Instead of returning 0, I return word.
Go on,
That's
Marin.
yeah, and then we have to shift by 2 more at the end because there are
uh,
2 more bits, like
Oh yeah,
to
yeah.
make
That's
32
also true.
so I need to shift to
2
the
to
right,
the
to the
left, to
left.
the
to the left,
left. Yeah.
to the left by 2.
Two.
Look at this code though.
Okay.
I mean, it's nice.
So
No, it's nice, but people reading will ask, what were they thinking? We are doing bit manipulation, man.
It's a
Okay, this is
virtual
so
okay.
machine.
nostalgic,
What
man.
did you expect?
This is so nostalgic. Holy fuck, man.
Nostalgic.
I did a lot of these doing university, man.
Uh,
Okay, so now you're gonna add to the memory a pack out of 6 instructions. Actually, we should
so
check if the array is 6 on the function there that we were.
so one thing we got import here. Uh, then we do opcode. Let's see if I even recall how to do a
It is
malloc.
like that. It is like that. But I think you use curly
Opcode
braces to initialize it.
Actually,
malloc.
I think you can just do stack
Yeah,
allocation in that
yeah.
case, though.
You don't need the dynamic allocation, Maget. You can use just static for this one because this is a temporary buffer.
Right.
So you can just
Let's
use curly. No, no, no. Don't limit it. Yeah, just remove the malloc. I use
just
curly
yeah, I
braces.
recall this. Yes.
Okay,
So
so let's
what are
make our
the
first
steps?
program then. So what the heck we're gonna do?
I don't know. Good question.
We can
Knock,
halt.
knock,
That's
knock,
fun.
knock.
No,
Halt,
the
halt
first one
8
needs to
times.
be. Oh no, the first no, there's no need to do the halt. Yeah, let's do halt
We
then.
only we only have stack manipulation and control flow and halt, I guess.
Yeah, we don't have arithmetic, which would be easy to test. So let's make 6 halts. That's fine.
No, but it's just gonna halt once, right?
No,
Yeah, the
because
first
the halt
instruction
is
is
not
gonna
breaking, right?
execute.
The halt is just printing, as far as I understand.
No, it actually breaks
It
out
actually
of the loop.
breaks.
Okay,
It
so remove
stops.
the break.
No, man, the halt should
I
halt. It shouldn't.
understand. I understand. Well, let's make a NOP then.
It just wants to see the rest
Yeah,
working.
let's
That's what
make
it
the
wants.
a NOP.
1, 2, 3, 4, 5, 6.
Um,
And then you
What?
just put add object, and then you call the function.
Access elements in scalar initializer. Well, uh, I could do this.
I think it's.
Or am I
How do
crazy?
you declare? I already forgot how to declare a static array C. Here. Thank you very much. Oh, you put the brackets afterwards. That's what you do. So you would do remove the star and put the brackets after the second opcodes. Yes.
So
and
6.
put a 6 there. Yeah,
You need to call the
And
function to
then
do the transformation as well.
right, pack, word,
Boom.
and then you have to pass
initializer.
the address of
Yeah, you
the
need to pass
opcodes, or is that
the reference, Magit.
Oh man, this
automatic
is
for array?
so,
I don't
yeah.
recall.
Look at this, man. It's gonna have a reference within a reference. No, no,
And
no,
then
that's
you
wrong.
push
You need to
the
pass
command.
the
Uh,
address.
here. What do you mean address?
Wait,
Like,
am I going fucking crazy? No, this is
well,
this is the.
I'm
this is already an array, right?
Oh no, that makes sense. That makes
Yeah, I'm
sense.
pretty sure. Yeah, arrays are weird because in C they are the only type that is actually passed by reference.
Yeah,
So
yeah, yeah,
you
yeah.
know,
Okay, so now
sometimes.
go to the halt and remove the brakeman, because otherwise we're only gonna see one
We
thing.
just return on the
Yeah,
halt.
just do nothing there. No, don't remove the return, because otherwise it's not gonna work.
So I'm just gonna do this.
Yeah,
Nothing.
yeah. It's
Um,
good. It should print 6 halts. Actually,
Let's
that's a
see.
lie. It should print a PC fetch, then 6 halts, and it's already completely fucking broken.
And the first
Uh,
instruction, which is a good
oh,
sign.
we don't have the registers. We need to configure the computer. Go to the main, man.
True. So here,
just set everything to 0, I guess.
Oh, you want to
so
do the setup
no, but
here? I thought about doing in the entry point.
no, this is currently the entry point.
No, it isn't. There's a main.m.
Yes, I know, but we are not doing anything here. This is just calling the execute, which is this.
Well, I thought we would do in the main.m, but
And
that's
let's
okay.
just do it here, whatever. We can change it.
Okay, so you need to add a few registers. You need to add ISR and PC for this test. So
So
how the heck you do that? I don't
registers,
remember.
I think it's just push. No, it's not a. It's a map, right?
It's a map.
It's
We
a
need to
map.
remember how's the interface to that.
How the heck do we add stuff to?
I don't
Oh,
think
I
we ever did
recall.
that.
We did. Set object for key.
Ah, okay, so we did.
Set object for key. This.
Actually,
So
we
what
don't
do I
need to
set there?
do we don't need to do more than PC, because the ISR, if it's not, we're gonna add ourselves later. So that only put PC there.
Okay, what do I add to PC?
PC, you're gonna put 0, I
0.
guess.
Okay.
And for key, string PC. Semicolon, and that should be it. Okay.
And
So apparently there's
beyond
no
boundaries.
fucking memory. What is the problem?
Beyond boundaries. So the ISR is not initialized, probably?
Oh, we need to initialize the memory, right? Oh, we just did that, no?
We did on the PC, not ISR.
But we didn't add object, man, in the memory. I'm so fucking confused.
But the ISR is actually read
Yeah,
in the
it's
PC,
ready.
right?
Actually, wait.
No, the value
It's
of
trying to
PC seems
set
to be
here.
fine.
It's trying to set here.
Yeah, but it should.
Yeah, what it's trying to do, it's speaking from the memory.
Yeah, but I think the memory is broken. What is the problem? What is the error message again?
It has one element. which is a long bullshit.
Which is an
It's an
NS
NS
number, which is
number.
an NS value, which is an NS object.
Don't know what that is.
And it's
Beautiful.
completely not useful. Okay, so we need to discover, is this because the memory doesn't have something at value PC? Or is this because ISR doesn't exist? I don't think it's because ISR doesn't exist, because we are making
Yeah,
it to exist now.
yeah, it shouldn't be because of ISR. It's probably because of the memory.
I
We're
think
doing
it's because
something
of the
wrong
memory,
there.
man. But it is saying in the debug window there that there is one element in the memory RAM.
Yes, it does. You can't
So I
expect the
am
value though.
very confused. What a useful
What
summary
a
that was.
useless window. Say
Uh,
index 4294 beyond boundary 0. So something is empty. So that gotta be the registers then. Count 2. So this is has one value. That's true actually. And this has one. The
can you do
heck?
the following? Can you pick the memory object at index in the previous line and try to print it for us to be
Uh,
sure that the memory
wait.
is not broken?
If I can peek, say it again.
The part of the code in the middle, memory object at index, print that.
So peek the object at index.
Yeah,
The
yeah. So
you
the
mean the
code in the
memory.
middle there of line 120. Yeah, memory
You mean the
RAM,
memory.
object at index. No, not peak, object at index, and then value of PC. And let's see if this prints. Because if this prints, that means that it's not that the problem. It printed? No. So it is the memory. It is the memory the problem. So we can't access object at that index for some reason.
I mean, I can do this. Yeah, we can't access on the memory. What the heck? Oh,
What?
this is a 60. Wait, let's
Shouldn't
do
that be an
something.
ID?
Let's do something less retarded. What is this? It's a long integer. Is that it? I print
I
long
think
integers?
so. I think it's LUD though. It's garbage. How useful.
Yes. Clearly.
Because
No
this is a
problem.
pointer, right? I
Yeah,
don't.
that's why it's out of bounds, right? Of course.
Okay, so I think we don't need to cast it actually on line 118 because this is a pointer.
This is an ID for a
Yeah,
64-bit integer,
yeah.
which is required here to be a 64-bit integer. Actually, I don't think it is. I don't think it is. This is
But
garbage.
I'm confused because value of PC is garbage, but it should be dereferenced. But that seems like a pointer address.
Hmm.
So something is very wrong. Something is very, very wrong.
Man, these IDs, they're horrible.
Yeah, Void
Really
Star,
bad.
man. Welcome.
This is really dumb.
Welcome to Void Star.
Okay,
Uh,
let's think. So how do we dereference the value? By the way, is that the limit of integer? So it overflew, I think.
what do you mean?
4,297,94,000,000. Isn't that an overflow? Int 64?
I have absolutely no
No,
idea.
30,
Could you
30.
decast this value of PC and make it an ID and let's print the ID to see what happens? Because this
Yeah,
should
I
be
don't think the
zero.
code will compile, but let's see. Yeah, it will not compile probably.
Okay, so
Uh, Let me just change
comment
this
this
then.
line. Comment the line that
Yeah,
is wrong.
yes, yes, I know. Just to compile, I'll do this.
Yeah, we just want to see the value of PC. You can even add a breakpoint if you want.
I will do that. Oh, don't need this. So let me hard code this, and then I put this as a p, because that is a pointer. And then I will comment this garbage. And then how do I put a breakpoint on this nightmare?
You did it last time.
I'll like this.
Okay, so what is the value of PC? It is zero. It is 0. It is written there. So that's not how you dereference. It's not, what we were doing is not dereferencing, man.
Well, that's how I know how to do it with void star, which is the case of this garbage.
Okay, so how to dereference ID.
Oh man, dude.
What?
This needs to be an uint64. There's no escape around this. But I think the problem was the class. That was the problem. This is a long. Oh, it's LOD, I think, right? Or
Maybe it's an LL. I don't remember. Uh,
Man, in numeric type, they have weird names.
okay, now it's even more garbage, I guess. Value
no,
of
that
PC
is
is
the same
garbage.
garbage as before.
Yeah, but I don't think casting is the solution, man, to this problem.
No, we need to cast to something to get the
Yeah,
value.
but when you did ID, it was actually saying that it was 0. Now
Yes,
it's
but
saying it's.
as an integer. But we cannot cast to an integer because that's downsizing something. And that's why it's complaining. Um, just one thing. What if we do from 64 to 32 here?
I
What
have no
happens?
idea.
And then we put 32 here. Or just
The answer. How is the right way to arc compatible? What is the right arc compatible way to do this? I think arc is the error that we are having. And the guy said the right way, don't do it.
awesome. So it just, okay, just capsize the number, but it's still the same dash. How do we pick this value? How do we pick this
There
value
should
we
be
want?
another way, man.
I know. NS number
I don't know about that.
from with number with int. And then it's this. And then it's an NS number. We did this before and it worked.
Okay, so what the guy is saying here in the post is to do the following.
So do we have that? We do,
Is to do the
apparently.
following. No, no, but wait a second. Wait a second. Try this first before we go to this nonsense. So remove the NS number after the equals. Just have the registers blah 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 blah, and remove the bracket and all of that. And then in the definition of PC, put a star before the value of PC on the left side of the equal.
Put a star
No, not there. Before the equal.
before.
Before no,
Object for
yeah,
the.
before
Oh,
that
what
as
if?
well.
Oh,
Yeah,
hey, what
now
if?
we instead of
Wait.
auto, do a type that you want.
Oh, 64,
See if
whatever.
it complains. It does.
That's bullshit.
Oh no, but this is because we are doing for no, don't do auto. Do NS
Oh,
number, man. Do NS U integer whatever. Okay, then I don't know. Then the guy didn't help. Sorry.
no, you need to do this trash. You need to convert to cast here as well, which I don't think
In
he's
his example,
doing.
you don't. He just did it.
Oh, so he's lying.
We need to understand better this ID system
Man,
because
like
it really doesn't seems like
he's
a void star.
man. I'm pretty sure you can do this with an NS number because he has this function here with number with int. Exactly this. Okay, but then what is this conversion bullshit? Interface cannot be statically allocated. Insert blah blah. Makes sense because this is a class. Uh, incompatible pointer with the blah blah blah. Okay, I'll just ignore this. And what do I have? If I just print 2. This works, I calling it a day.
It does.
And it just increases the number by a
It's
lot.
even worse, man. It's even more garbage. Okay, so we definitely gotta understand better what this uh, d how to dereference a pointer.
So the problem is that that's not just a pointer. That's a pointer to a class. It's like C++. It's like you're trying to do a cast, but it's in a class. So you need to do the dynamic casting.
Yeah, but that's really what I don't understand.
What I find garbage is that it returns this ID, but then if you try to, the ID has the pointer size, which is 64.
Okay, can you do this? Like I found another guy talking about this problem. I'm gonna send in the chat. There. I don't know if this makes any sense, but the guy is saying to do that, so why not just try it? So apparently there is a function or something called integer value, man.
Oh,
Man, you've got to be kidding me.
That would be very, very weird. uh, so you do that, and then you do integer
Oh man, you've got to be kidding me.
implicit conversion to int.
I hope this works.
Ooh,
Okay.
he's not complaining. It is zero. Haha.
Man, so all we needed was to just use the correct function to get the actual value inside the thing,
so
and
they
nobody
have
tells you.
so they have
Oh.
separate functions for dereferencing. That's so weird.
Which makes sense. It's delegated to the class to
But if
handle
you're
how
gonna
you
do it
get
like
the
that,
thing.
why just not depend solely on the casting?
Yeah, that's a
Weird.
question I don't know how to answer. Uh, does it work? It
that means
didn't,
we have
Default.
to
Something is
change
wrong.
and
the basic.
it
That means
didn't
we
Oh,
have
I
hit
to
think
the
we
change the
halt.
removed
basic.
the halt. I think we removed the halt. That's why. Go to
It did not.
opcode and add the halt, man.
Wait, the halt is here.
No, it's
Oh,
not in the
it's here.
opcode.
Uncomment the return, I guess,
Oh,
is
the
what you
halt
mean.
is here.
Oh, the halt is there actually. So I don't know what the heck is happening.
We commented the return statement in the halt.
And
No, they should just ignore this, right?
no, it should
It should
print six
print at least.
times. It should print halt 6 times. That's what it should
What
happen.
if we put here? But yeah, I agree with you. I hate that it
Oh, it printed
covers
a
the result.
default. Why did it print a default?
Because it means
Because
that
we
the
have
if is bogus. That's what it means.
Yeah, it means it
no,
got here.
we have to man. Does does that mean we have to like hmm,
I think
Now
that the
let's
PC fetch or the shifting mechanism is wrong. One of
let's
the
oh,
do
I
one of the
mean
the
two.
let's do
my
this.
first instinct actually would be to look at every place that we read a value from
So first
the
time
register.
0, first time 0,
That makes sense because we're gonna do the PC fetch.
second time
It's
PC fetch, now
27.
27.
27 is definitely wrong.
No, but remember, you know how we just called integer value on the return of a lookup, right?
Yeah.
Mhm.
We have lookups everywhere. We have to change every single one of them.
Oh man, that's true.
Well, at least for today, the PC fetch needs to be fixed.
Yeah, but the PC fetch is just returning bogus
No,
stuff, right?
that that's not the thing. The thing is actually up there when we fetch the instruction from the ISR. That's also a lookup that has
Oh,
to be
that's true.
fixed.
That's true. Let's go to the beginning there, Maggot. Yeah, line
Oh, here.
44.
That's true.
So instead of doing that, we need to do integer value.
This is really border. This is really the definition of cringe, man.
Now it
Ah,
should work better. So restart the program.
Yeah, there's like in more places, but
Yeah, but
since
we're
we're
gonna
not
have to
relying
fix
on
this
them,
later for the sake of. We're gonna have to fix
so
everywhere.
first time 0,
That makes sense. PC
second
fetch
time
6.
6.
That's promising.
Yeah, now it is right.
So
Okay,
this should be
so
halt actually. Halting.
halt,
it
Next.
is.
halt,
Halting.
halt,
Halting.
halt. Exploded.
Wait, how many halts
That's
did
fine
we did?
because we
Let
1, 2, 3, 4, 5, 6.
five,
Okay.
six. Okay, so it's correct. Because now we
One,
had zero,
2,
which
3,
means
4.
that we try to fetch more
1,
stuff.
2, 3, 4, 5. 5 actually. When it tried to do the 6, it failed.
No, but the
Okay.
error message is on the PC fetch. Doesn't make sense to have only.
Yeah, it means that it basically did 5. It shifted once more, I guess. And then it went out of range. And then I tried to do a PC fetch and failed. Actually, it failed before doing a PC fetch. Where is that?
No, but that makes sense. Trying to do a PC fetch would make sense because we don't have any more instructions. We don't have a halt, a real halt, like a finish, an exit. But it's wrong that it's only five haltings. It should be six. Can you go up? Can we see the array again that we just did with the halts?
The
Maybe the
array
for
that
loop
we
is wrong.
did with the halts.
One,
This.
two, three, four, five, six. Okay, go to the utilities now, to the pack word. 0 to 6. I'm confused. Am I missing something? Um, okay, so do the following, Mageta. Before printing the word, before returning the word, print it. Do a log of the word.
I mean, with this, I guess,
Well,
right?
yeah, with the shift 2. I'm gonna discover what's the bits, what's the number that should print there. Um, so how you do 6? You do 0, 1,
This
1,
is
0.
a
Yes, this
D.
is number 6. So is this 6 times? 2, 3, 4, 5, 6, and then 2 zeros at the end.
How do I print this garbage? DU?
Uh,
Mm, M?
Probably UD?
No.
No.
Ah, man,
LD?
CMAP.
LD,
No.
LDU actually. Yeah, I have no idea. We have to search. So let me go to decimal. What's this
Int
number?
32.
You gotta be fucking kidding me. 2, 3, 4, 5, 6. Go. Okay, so I do have the number that should be there.
Which is?
Uh,
No,
26
make all this.
million 80 40 843,544. ZU.
ZU, man, what the heck?
Cool. Doesn't
It's
seem
not
to be
ZU.
that.
What? Oh, I'm dumb.
Maybe this is still
It's not
wrong.
ZU.
Okay, print format special something something.
Try using ZU in both cases.
Yeah, the guy saying ZU both. LU is also being
LU.
commented.
Unsigned long. That's not the case. It's not a long we're printing.
Oh, GD. No, no.
G. Oh,
No,
no,
no, but
this is
that's for the
E.
max integer in C. That's totally a different thing. Yeah, people are just suggesting to use cast. Oh, there is a macro apparently, man, to do that.
I mean, it's just U, I think. Yes, it's just U.
Okay, so return word. Yeah. Okay, so now you print. Go on. I have no idea what
Excellent.
that number is, man.
So either the mask is wrong or
Or off by a little bit, actually.
No, this is completely wrong. This is like 108, 831 million, no? Or is this in Exa? Is this in Exa?
oh, there's a this didn't pick on the
I think this
mask
is in
though.
Exa because there's a D there. Yeah, it's also not
No,
the
no,
case.
it's not the D because of the mask. I was trying the mask and it doesn't pick the same. You see? U, U. I think
I'm
it picked
Oh,
it.
68.
okay,
Why
okay,
am I
okay, okay.
68?
But it's unsigned. Man, it should be U something.
Oh, I think I see the problem. Yeah, I see the
Weird.
problem, actually.
E.
No, it's still
Yeah.
bogus.
Here,
What's the problem, Marinho? Enlighten me.
This is the problem. We're missing the final instruction.
But that doesn't make sense. That means that the for loop is wrong. We don't know how to do a
Yeah,
for loop.
that means the
Am
like
I?
I don't get that we are just processing
Oh,
five
no,
and then it
this means two things. First off, the for loop is the conversion function that packs the instructions is wrong. But actually, it also means that the execution is correct because it executed 5 halts and then a fetch, and the fetch failed because we ran out of memory. But that's
Mhm.
fine. We only have one memory cell anyway,
No,
so it's
that I
expected.
understand. I understand the execution. I was expecting to fail, but I was expecting to fail after 6 halts.
yeah, you just
Yeah,
have to
but
find.
this just means we messed up somewhere in the conversion, in the packing function
Yeah, no,
somehow.
the
Yeah,
for
but
loop needs
how?
to be wrong. But how?
It's going from zero, is going six times, doing ORs, doing shifts on the left on five, and then does final two shifts. Oh, two shifts is two, and then it just returns. That's it.
How does that make any sense, man? Marinho, please. Where? How are we can? How are we so stupid? How is this wrong? I understand what you sent. You sent basically that the remaining 8 bits are zero instead of only the remaining 2 bits, and that explains the number 832 million 283,968. It's exactly the number that Magetta has.
Hmm.
But
Yes.
how is this possible?
Let's see. We do that, then we do final shift.
While you guys think of it, I'll be right back. I'll go grab tea.
Okay. I don't know, man. It's a mystery.
What do you mean? I'm starting to think that we are doing an extra shift actually. It's not that we are not masking with an OR. We are, but then we are doing an extra shift.
Oh, right, right. The shift should be before the or, not after.
Okay, that makes sense. Okay. The fuck, man? Okay, but at least we discovered the problem. And it's already like almost midnight, and I should have done other things, but it was too fun, man. That's unfair. Why fun things? It's not the things that I need to do.
Okay, what is it?
We discovered lines 23 and 24 should be reversed.
Oh, you're kidding me.
No,
Why?
because we should not do 6 shifts. We should do only 5.
Six shifts, we should only do five. Oh, I see. Because after with last or, it will shift. Oh man, I see. So if you put this before
Mhm.
here,
Yeah, now you can run it again.
let's see. Yeah, that makes sense.
Let me
So
see if this
okay,
is the
it
number
didn't
that I
blow
have.
up. So zero. Oh wait, not this. Okay, PC fetch, alt, one,
Okay.
two,
3,
three, four,
4,
five,
5, 6.
6.
Nice.
PC
Now it
fetch
should break.
out of
Now
memory.
it should
Okay.
break out of memory. Yes.
Okay,
Okay.
let's just add a message here saying we are out of memory.
No,
Uh,
not there. Just put in the else.
let me see. Well, not in the else in the
Not in the
throwaway.
else. We need somewhere to put this thing, man.
That is actually a that's an exception, right? So
Yeah, we should do a catch on the on line 119, and then we
yeah.
should do a catch of the
So
exception out of memory.
let's do one here. I guess.
Yeah, there. So do a try
Try.
there. Then we you add the line
Um,
before. Well, the two lines before actually. Then
put this
if the
here too.
exception is thrown, just copy the exception, the line 128. I mean,
Mm-hmm.
and then the message is gonna be go by memory.
Uh, how to say oh in English?
OH,
Uh-oh.
OH.
It's
OH? Oh,
actually
no, that's
no,
like
it's
oh
actually
ho, like laughing.
No, no,
it's
OH
like this.
space OH. Or you the way the Marinho said, UH space OH.
Oh, like okay, oh, like
Yeah, but
this.
Marinho suggesting to swap the first O with an U.
Uh-oh.
Oh, I see.
Yeah.
Oh.
And this should not be a log, this should be an exception.
Yeah, but well, we're gonna launch an exception.
No, we're not gonna. Well, we're gonna launch an exception, but an useless
Actually,
exception.
we should. Never mind. So let's do this. I was thinking of doing something else, but let's do like this. It's certainly not the stack underflow.
Yeah, this is
We
like
will
lack of memory or.
lack of.
OOM.
Sorry,
Oh,
OOM stands for out of memory.
yeah,
out
OOM
of
stands for
memory.
out of memory.
Let's write this out of memory.
The error message. Uh, you need to put, yeah, and then you also need to put the user info apparently, whatever that means.
I think it's the stack trace and stuff. If you want to put who is running this for like apps.
And it's not bracket, it should be parentheses. Oh no, it should be bracket, sorry, should be bracket. Okay, now you can run it again without the breakpoint.
Okay, so let me first do one thing instead of just blowing up. I'll try to do a graceful. Uh, should I
What do you want to
print
do?
gracefully? I want you to print gracefully instead of just blowing up the stack trace. But let's just do it. Let's just keep it that way. Screw it.
PC
Uh-oh.
fetch, halting,
Run out of
halting,
memory.
halting, 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 PC fetch. What is the exception on the top?
Run
Go
out of
up.
memory. Run out of memory.
Ran out of memory. Haha!
Right.
It works!
So I will commit it. It's definitely not parsing, but I will commit it.
Yeah, this is just like fixing the program counter cycle or something like that.
We we downloaded some memory, so we have RAM now.
No,
We
but
added
we
some
also
throw.
we had memory from my commit. Now we had
Oh,
non-empty memory. That's the difference.
right. We have actual memory, not just a slot for it.
Oh yeah, that's a good analogy. I added the slots. Mageta added a stick of memory.
Zero memory. Okay, I need to delete. Let me see. You committed with the DS, right? So let me delete that.
Sure.
Uh, there we go. Do we have that on side chime as well? Oops. We do. Thank you, macOS. Definitely not this. RM. And I think we're good. Okay. So I will commit and I'll change the name of the branch. So add memory, I guess. Oh, not memory, but the uh, branch
And the thing is that we
name.
made a very important decision. We made the decision to support 32-bit machines just for the sake of PowerPC to be able to run.
That's a wise decision. You will not regret.
Ah man, I'm gonna clip this 10 seconds of you saying that, and every single time you complain, I'm gonna send the clip. Yeah.
Let's put like this.
This was fun.
No, it
Yeah,
was
we
fun, but
did.
the problem
We
is
did.
that we need
We
to
did quite a lot
refactor
actually.
basically the entirety of the rest. We're gonna have to
Okay,
redo the dereferencing because we just discovered that our dereferencing was completely bogus.
please just review and let's do the parsing. Oh,
And
it's
we
almost
also
midnight.
gonna have to fix all the 64 bit operations that are potentially happening there to be 32 ones.
Yeah. Fair.
Best answer, man. Best answer ever.
I find it funny how you see people Lemos committing everything, and then I just say add memory, and I commit the hashes.
That's okay. That's okay.
Okay, so just review that, and uh, I need to go because it's almost midnight. But I think I'll try to do the parsing, my free time
If
anyway.
you do the parsing, I'm gonna do the well. At least I'm gonna start the gigantic refactoring, changing everything to 32-bit, and also um, doing the dereferencing correctly because now we know how to do it.
Yeah. Mm-hmm.
Okay,
Uh,
so I'm gonna
of
finish the recording
integers
now.
at the very least. And all integers just be
Okay, so stop the recording.